1, 2. Oh, hello. What are we doing today? Guess it's all in the title. I gotta figure out music, because music is apparently illegal, even though it's not gonna propagate to YouTube or to the VOD. So I've been uploading a lot of VODs, and copyright is one of my problems, just because of the metronomic live music. So what I'm do? Let's see. Should I round the edges of the border? The inner edges of the border of my YouTube is it's a square edge with a rounded border. We've been dealing with snow for the past day, so I didn't stream day before yesterday because we had a whole bunch of snow. So what am I doing? Wait, when did it snow? I don't remember. Let's do, I don't know if I want to do OTT again. I haven't had music in my heart in the past couple days. I've just been working on stuff, been uploading videos. I am a machine that turns VODs into YouTube uploads daily. It's been pretty interesting. There's a little bit of traction too. I got like 400 and 500 views on 2 videos, and I think maybe that was YouTube pushing my content to try to get me to go viral, and me having too long videos and people not being interested. So I think editing is inevitable. Editing is going to happen soon. I have to find that copy of what's the program again? Adobe, the old copy of Adobe that my friend has, and set it all up to churn out edited content, barely edited content. YouTube. There was that post of music in the music channel that was like super hard chiptune stuff. That was awesome, but I don't think I'm going to use it. I don't think I'm going to use it. I have game music. Oh yeah, test to see if this stuff will. Master Blaster, High Fleet. Nah, let's just do one of the. I think I got an album in here. We can do that like kind of hard chiptuning album maybe. Sorry, this needs to move like all the way over here because I'm like craning my neck to see the third monitor. The 3 monitor setup is really good for like editing video because I can throw stuff way over to the side, so I'm not distracted by stuff. But then when it comes to streaming, it's like this is the shot that I get because I'm like craning my neck over. Yeah, I think it was actually an Adobe suite from a long time ago. So it was everything. I could do motion graphics and all that stuff. I just wouldn't have any of the recent features that Adobe has because it's not a one of the rented copies. There's a friend of mine who does video production, and they do all Macintosh, but the package they got came with a copy for PC that I could just steal. He was like, "Yeah, you just have it. We do literally nothing with this." All right, I gotta make sure that my speaker volume is not. I've turned the speaker volume up when I'm editing. Of course, I should edit on my other computer. I need a drive for all the mess that editing makes. It's like gigs and gigs of video data that I don't know what to do with. I don't want to keep it. How's that? That's a lot quieter. It's probably coming through on my mic, so I'm gonna lower this even more. It needs to be whisper quiet. I should get wireless in-ear monitors. Yeah, isn't that great? But it's not the newer copy. It's an old version. So I have to look up like ancient tutorials on how to output for YouTube instead of using features that might be baked in already. All right. So I did like 10 minutes of work in Fusion just to make sure everything was proper, and then we could work with this because we're going to be making this into mount points and things I need and don't need. This is a separate file. I cleaned up the directory a little bit. We need to make opinion. We need to make the differential, and then I need to do the attachment points on the back of the differential housing because we'll make new ones. We can make a straight bar that goes across. So I'll have to measure the distance so that I can get it to be in line with these two. I'll figure out what that distance is supposed to be, which means I probably need to undo the A-arms. I know it's 16 millimeters between them though, so maybe I could just do 8. and then we'll put an attachment point there. I'm going to try to use generative design. I think it's about time that I learned a little something about that, because we need to make a minimalist bracket that's going to replace this, and that'll be one attachment point. We need to figure out what exactly is going to be, what the servo is going to be screwing to. I think maybe it'll be a door from below the model that'll attach the servo, and the electronics will go in the base of that, maybe? The electronics are a thing that I fear as well. And then we need to get the differentials into the two housings, so I think those are going to be a door as well. Two doors that have cutouts for the differential and mount points and stuff like that. It's going to be a lot, actually, and I don't know if we're going to totally benefit from... Let me open the printable one. I'll go over this again anyway. Missing a day of streaming and then you don't get any viewers. Because it's so lengthy between your streams. I want to see if generative design can build a frame for this RC car. Make it pretty much the same dimensions, but it'll be full of spider webs or whatever. I have access to it with the educational copy. I started to do a little bit of the electronics design, and it kind of got out of my attention span a little bit as I was uploading videos. I don't know. I don't know how to fit this stuff. This is perfectly viable, though. I can make this work, because I'll have something that screws down from below with like 1 or 2 screws, and then these 3 will come up from above, the 1, 2, 3 back here. Yeah, I think the best thing for us to do is you map out attachment points, and then you give it a solid where it can make the generated design. And so it'll follow the solid, and it'll do all of its structural stuff inside of that solid. Instead of giving it just attachment points and forces, we can give it attachment points, we can give it forces, and then we can also give it a frame to stay inside of. Because I think at this scale, this is small. I mean, this is not big. This is this big. This is the palm of my hand, and I have to 3D print it. So model's a lot lighter without metal wheels. By the way, I put the plastic wheels on it, and I don't know if I appreciate it so much. It'll probably crash once and explode these wheels, though. Yeah, like this. I don't know. Also, these wheels are a little bit rough on the support area, so they're not exactly totally true and straight. They're not like the metal wheels. The metal wheels actually have tolerances. I don't know, it feels cheaper with the non-metal wheels. But yeah, this is not big. So the structure of a generative design doesn't have a lot of room to function. It doesn't have a lot of room to do what it does. I think maybe at a slightly larger scale it would do a bit more. Whoop. There you go. Had a video about a similar thing. AI made an intake for the 12-rotor engine with its parameters. Whoa, that's cool. 12-rotor engine? Holy crap. But that's like a big project. This is like not big. This is small. Everything changes in this scale. And unfortunately, like, you know, oh, let me do a generatively designed A-arm. Well, the problem is the A-arm is already incredibly minimalistic. It's just the attachment points and then a small amount of aluminum between things. And it's like you can't really do much unless you have a microscopic 3D printer. I wonder though, because I was thinking about it for this car body, because there's a little bit of room in the car body, not much though. And if this was all a big unibody, what would that be like? I wonder if the motor probably has to come in from above, unless I do an under cutout so that it could come up from below, but I don't know how that's going to print. I don't know how that's going to print. I want to give it a shot, though. I want to give it a shot because it seems funny. So it seems funny, and it's like a popular thing. Maybe people will click on the video, but we have a couple things to model before I get to it, like the pinion gear and the differential. He used Fusion. There's also, who's saying, it was Chester was saying that SolidWorks, I think, has it for free. They have it for free. But I'm not about to install whatever the other Keeper of Maps. 4 years. When did that happen? Keeper Maps. Dude, I'm editing old videos, and you're in a lot of them. My videos from 2 years ago. You're all over the place, man. But it's good to have you. Thank you for subbing for so long. I don't know why you would support somebody for that long. It seems like a kind of a character flaw. I appreciate it. Why is that bent? Why is this bent? It's like bent. Why are you bent? Stop being bent. Weird. I just need one of these housings to observe. I spent a lot of time on this model, just kind of getting it right and learning Fusion. I watched one tutorial on generative design, so now I am the smartest. There will be none as smart as I in this subject. None. None can approach me. My brain sparkles in its smoothness. Yeah, so this is what we have to model, including the hair, but especially the hair. What's crunchy? Why am I running into crunchy right there? Oh, there's a seam from the injection molding. Here. There you go. So one on the other side. Nope. This is my last one of these ball differentials. The other one died in a crash. In slightly larger scale RC cars, they make this part out of metal. Guess which part broke on the plastic one? Always, always, always. Why use all these different bearings? They sure do love their different bearings. I have to relearn how to make gears. There's a gear plugin that I can use. But yeah, this is essentially what we have to build. And all those bearings will be our sort of like keeper points where generative design keeps a thing. Cool. I'll check that out after stream when I can break away. My post-stream ritual has become quite involved, actually. Quite involved, because when I end, I have to go walk the dog, prepare dinner for everybody, and then do all this other stuff around here. So it's a process, and it takes until like 7 o'clock or 8. It's usually around 7 o'clock that I have any time for myself, and my brain is just broken by then. I'll bring you guys down just a little bit. There we go. How's that view? Keeper points, yeah. Well, keeper of maps and keeper points, yeah. I think that's why my brain decided to fill in weird. But they're points that you want to keep. They're things that you want to exist in the final design. You're like, this is a thing that needs to be here, and I need you to accommodate for this amount of force. Now, the force accommodation, we don't know anything about. I don't know anything about it. I don't know a damn thing. I don't know anything. That's going to be kind of a weird part of it. And then the other part of it is going to be, at one point, is Fusion just going to make the whole thing one solid piece of plastic? It'll probably make the whole thing into a solid, organic-looking piece of plastic instead of the sort of webbed design that we're looking for out of generative design. So we're going to have to violate some principles and say, hey, you know what? You only have like a few grams of force that you got to deal with. Don't worry about it. And it'll be like, okay, let me put spiderweb design here. And that's when we'll be like, yeah, we did it. And then I'll go to print it and it'll explode. So I don't think we're going to get to see any of the generative stuff today, because today we need to model all of the additional components that are going to allow me to put this together. Then I need to run the generation, and that's going to take a long time. For the example, the example that I saw, it was 4 posts, like 4 attachment points, and then a center pivot point. And they assigned all of the like 8,000 foot-pounds and all of the, you know, lock these here, keep these here, put this here, this is this much force in the XYZ, and it took an hour for it to figure that out. So, you know, by the way, if you use the generative design too often as a free, what is it, Cloud Points user, Cloud Points are their way of limiting the amount of server traffic on their cloud so that they can remain at least viable for other people to use it. But it's use Cloud Points, so it's probably like, it's like fucking like Steam points, you know, or like some kind of another microtransaction system. I don't know who they're talking to and why they think that's viable in like a professional program, but it's kind of annoying. Not that we ever need to use Cloud Points. So I shouldn't ever use them because it's part of the paid tier of Fusion 360, and I like to keep things on the down low. You know, I tried to teach you guys about like the free tier and not go out of that. But I think generative design's too interesting, right? And sometimes they have free generative time so that people can like get used to it and they can stress test their system. So in that vein, I want to try out generative design. If I use too much traffic, if I do it too much, they can restrict your account even further. So I don't want to get on their radar. Cloud Points sounds like vaporware. How many Cloud Points do you have, man? Yo, can I borrow some Cloud Points? I need to get this Fortnite skin. Yeah, it's very microtransaction-y. Clouds aren't real. Stop telling me clouds are real. They're not real. Have you ever flown through a cloud? It's not real. I don't know if I'm going to be able to find all these bearings. We found this one, but it was the outer diameter only. The inner diameter wasn't represented. I need each bearing. I probably need the diff just so I can do like a keep out area, and the pinion we probably need as well. But then I'll put a tube around the drive shaft to give it just an open space in there. See how that works out. But then this stuff is going to get held on likely by like a bracket that bolts in from below. I don't know how the drive shaft's going to get in there though. I have to figure that one out. I don't know. I have a feeling this is all just going to be crap, and the generative design stuff is just not going to work. Just because it's not going to make a really cool looking spider web, you know, like Spider-Man came by and was like, bah! and like made the car. It's not going to look like that, just because I think the forces, well, we're not going to accurately represent the forces, but I think the size of everything is very compact in this model, and I don't think it'll work that way. It'd be cool though. Be cool though. What else do I have going on? Nothing. I've been snowed in. No, none of the content creators that I follow have been making content. I think some of them are on vacation or something, which is totally, that's fine. I support that. I support content creators taking a break. I haven't done that in a couple years at this point. I haven't taken a single break. But other stuff that's going on, snow shoveling. Willow was very cute in the snow. I shared at least one video of her playing in the snow. That means that I can't do any of the RC car stuff, so I guess it's a good opportunity for us to do something crazy or finish this. Julian contacted me. Julian contacted me about a module. He wants to build something that is basically just a Vactrol. And a Vactrol, for those electrical engineers out there that don't know what a Vactrol is, because that was me, it's just a compressor. It's a compressor for audio signals that simply uses a lamp and a photo, one of those photoresistors, right? Apparently that's fast enough for audio. I didn't know that. But anyway, it was a photoresistor and a lamp in a tube, right? The classic electrical engineering kind of shit. That's a Vactrol. There's a place that sells Vactrols. I don't think they're adding a whole lot of value to the concept of Vactrol by getting it from a specific place, but Julian says he has some. So this is a module that is almost entirely just a Vactrol and some diodes. So I could 3D print a panel for him and have that done you know, in 5 hours. Let's be realistic. Every time, the more simple the project is, it seems like the more time it takes. Paying my dudes for all the questions I ask. Brink GG subscribing for, I gotta bring this up, where is the page? Brink GG subscribing for 9 months. Dude, hell yeah, you don't gotta worry about paying me. But that's awesome. We got Keeper of Maps for 4 years. Brink GG in here for 9 months. Thank you, thank you. I do very much appreciate you guys subbing, and it's very nice, y'all. Nobody's under any obligation except for Brink. He has to. He actually has to. Got a contractual obligation. He signed some forms. They signed some forms. Hey, Complex Sweet, what's going on? I'm just trying to fill the air until we start out here, but just thinking about, like, what have I been doing over the past weekend? I don't know. I don't remember anything. What did I do? Oh, no, I didn't do that. That was last week. What did I do? I've been hanging out with my dog a lot. A friend of mine called and was like, yo, do you want to, go to the bar and get some food? And I'm like, first off, I already ate. Second off, I'm not drinking during the day. So it's like the whole thing was just bust. I'm like, I'll see you later. Oh, you should just go to drink. No, I'm not going to ruin my whole evening. Like, I got shit to do. Actually, I think it was the middle of the afternoon. They wanted to get a boozy lunch. And I'm like, hell no. I can't do that. I can't concentrate. Yeah, it's been pretty much like my entire pastime over the past, couple days has been uploading as much as possible so I can get ahead of today's date, because today's date keeps marching on a 24-hour basis, right? And I was scheduled with videos up until close to the end of the month. Now I am at the beginning of next month. So it's like there's this constant looming deadline, and if I can get ahead of that, I finally figured out the dog is important. She is. She's very important. It's nice spending time with her. Did I cook anything? I cooked a stew yesterday, and I screwed it up again. I can't get stew right. I don't know what the deal is. I think I need to follow a recipe to the letter, use the Dutch oven, and put it in the oven for 2 hours instead of trying to super slow cook the stew meat, because it's been drying out. And I think one of the other pieces of advice that I got was raise the temperature when you're braising the beef. So oil in a pan, high temperature, like 300 degrees C, throw small batches of the beef in there in order to get your Maynard action, the caramelizing action on the outside of the beef. Move it out, next batch, whatever, until you're done that. Then lower temperature, veggies, move the meat back in, all your juice and stuff, throw that in the oven for 2 hours, no more, no less. I think at 350, I'll have to look up the temperature. But yeah, that's been sort of I've been having problems with the beef, like, being totally dry. This is on the brink. This is on the very edge of being totally good. But the shreds, there wasn't enough stuff holding the shreds together. They kind of blew apart too easily, and it was just a little bit chewy and dry. Having beef with beef, yeah. I got beef. What if you got? What is the line? It's who's that? I got beef. No, if you've got beef, I've got vegetables. So if you want to do something, you can leave with a full stomach. I don't know what the interline. Some it's a rap song. It's a hip hop song. I don't remember. If you've got beef, I've got vegetables. Something. You can leave with a full stomach. I don't fucking remember. I can't do this anymore. I can't do this anymore. I got to get out of here. God, anything else going on? Oh, you guys want to know why I'm not drinking? I had a weak moment. I bought a parts cleaner. I spent the money. I did a little research. I basically looked it up on Reddit and found a really good model. Teams calls summoning. All right, Keeper, thank you for hanging out. I appreciate the lurks. The lorks. Yeah, but I had a weak moment. I went and bought a parts cleaner. So I will have that now. So we will no longer be swimming in goof off and flux. Instead, we will be swimming in simple green. I mean, I'm still going to use this stuff like where it's necessary, but I will be able to at least throw a board into the cleaner and have it come out pristine. So I'll have to, I don't know if it comes with simple green or not. I'll get the parts cleaner and then I'll get the simple green in classic Slacker fashion. I think it's gonna live under here, and I'll move the brew stuff into the storage space because I haven't used it. I have a whole control system that I made, like, how long ago was that? It was like when I started streaming. It was around 2016 when I hadn't put up tiles on the walls or anything like that. Around 2016, I built my all electric brew system. It's a great system. I love it a lot. I should still be making beer with it. I feel bad about that. I'm gonna go get water at Acme if I can remember to tonight, and then I can make mead. But the brew system was awesome. I got like an induction hot plate and everything for it. A lot of really good equipment went into there too. I eBayed a lot of DIN rail stuff, and that's sitting in a box under there with a Raspberry Pi brew system. A Raspberry Pi brew system that controls all the heater and everything like that, and the timing and stuff. Was the parts cleaner expensive? It wasn't cheap. It wasn't cheap, but it was like 3 meals if you or you're ordering out. It's gotten so fucking expensive. So the parts cleaner could go down there. I'm gonna move all that stuff off into storage. I have another enclosure that I would love to use to put together the brew table again and have all the industrial controls below, and then have the monitoring stuff like the Raspberry Pi and the emergency stop button above. And that way, you know, you've got 2 panels, and one of them is all the high current switching stuff, and the other one's all the low voltage controls. So that's something that I would love to have happen. We haven't done it for 2 years, and I need to clean more of my project queue before I even start to consider that. Those ingredients in the back of the basement are probably pretty bad shape. Barley that's like 5 years old. Oh boy, I should have put some of that out in the garbage today. Which sucks because I have some good recipes. I'll we'll get back to that at some point. I loved brewing beer. It was a lot of fun. But yeah, the parts cleaner is something that I probably needed for quite some time. I refused to get one because I wasn't using all that much flux. But some of the boards that we've cleaned in the recent past, after doing a little solder rework, have like desperately needed something else to break away all of the BS that sort of cakes in from heavy solder rework action. Oh, I need to pop out YouTube chat. Hold on one sec. Oh, did that? One of my favorite moments on the VOD that just went up was my tier list of tiers. My trail of no, wait, no, that's different. Let's see, pop out chat. There we go. Okay, so just in case somebody jumps into YouTube, every now and then we get somebody jumping into YouTube. The the situation with the YouTube videos. Oh boy, the situation with the YouTube videos. It's bad. It's real bad. Look at this column. Copyright, 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 copyright. This is from 2 years ago when I did my month of gaming, which I really should go back to. I think every January should become month of gaming. Better December. December is probably the better one for the month of gaming. But like we played a lot of Satisfactory. We played a lot of varying games like My Summer Car. Oh wait, that's it. That's all we did. All we played was My Summer Car. Mon Bazo a little bit. I got to play Mango, which was kind of neat. Looking back on it. But yeah, these copyrights are killing me. And the only respite that I could possibly have is by going in with video editing software and deleting the entire intro and music, and any BRBs, cutting that out too. Otherwise, I mean, but that like ruins the conversations that we have. So I don't know what to do about that. What are we getting views on? Woo, 585. RC, huh? Arranging posts in Fusion 360. Really? The other one's Satisfactory. Satisfactory is galling me. This is before I got the convention of my titling. So that went out 27th. 400 views, 8 likes. Holy shit, I'm like famous. More RC stuff again in the tops. Yeah. Satisfactory and RC stuff. I'm starting to see where my channel's gonna get pigeonholed in too. 124 RC working continues on the thing. 116, 112, 115. Damn. Well, that's cool. I love seeing it. You love seeing it. I don't know why you guys are watching my videos. That's embarrassing, but I appreciate that. Because this, okay, so you guys should know this is just like a dump of all my VODs from 2021 on. So things are going to be like, it's going to churn for a while and then it'll kind of cool off because we're live streaming to that channel. And then I guess what I'll have to do is once I catch up, I will then publish the live streams to the main, the main video feed, and I'll give those title cards and chapters. But what I'm hoping this does is when I catch up, or even when I catch up a little bit more, I will be able to have an idea of what the hell happened during all these streams. There's all 5 hours, and there's a lot of there's some downtime because it's like I'm carrying the conversation myself, and we're trying to figure something out. There's like 2 hours that I was figuring out where to do the wiring in my summer car. So I can cut stuff like that short. And then I heard some YouTubers are leaving the platform. Why would I leave? I'm entering the platform. Oh, you're saying now's my chance to seize the vacuum of content. Yeah, a lot of people are retiring, but they're not anywhere close to my level. We're talking about like Tom Scott and like the big boys of YouTube videos. So, but yeah, if I could figure out a little video editing, music is going to be the biggest thing that kills me on that one. I don't know what to do about it. Don't know what to do, but if I can make some edited content, it'll be more attractive to viewers. 5 hours a day, it's like, I don't know. People aren't going to watch that. So I'll have to start looking at those chapter call outs. This is like how we used to do video back when I was in high school. We had to go through the VHS video and mark down on spreadsheets the stuff that happened, and then you would go through and you would edit and record VCR to VCR. And our art teacher at the time had the good ones. He had the actual synced up dual VCRs instead of what some amateur video people do. Get your and your buddy's VCR, and then you have to hit record at just the right time, but the record wouldn't happen instantly. The head would have to spool up and the tape would have to start moving to the right speed. So you'd have to time it so that when you hit record, the thing you wanted to record was on the video and everything was running without bad tracking issues and stuff. So what they did is the more professional setups would have 2 VCRs and a sync cable in between them, and that sync cable would make sure that the timing is already catered for, which we had. I was spoiled until the IMAX came in, and then it was all digital video editing. But I didn't get to digital video edit that one video for, what was it, the sports video. So I didn't have to play a sport that season, but I had to record a bunch of stuff and make a whole video with people doing sports stuff. And it's like, I don't want to do sports stuff. Why are you shoving my face in it? But I made a whole sports video and it sucked. It was the worst. I played it in front of everybody. Everyone was asleep though. It was an assembly. But anyway, I'm doing something like that with the chapters of the long videos so that people are able to watch it piecemeal if they feel like, or if they want to just skip through and see the cool stuff happening. Especially in my summer car, that's tough. There's a lot of transit time in between things. I want to play my summer car again. But yeah, people can watch it piecemeal, and then I can come back in and look at the chapters and go, oh yeah, that's what happened there. So let's take this, let's take some of this, let's take some of this, put it all in the video editor and go, oh my God, it's 10,000 gigs and a 4-hour-long video. What did I do? And then pare it down into the really important stuff and do a voiceover, I guess. I can steal Rob Ozz's style. No, I'm not going to steal his style. Anything else happening? It's been like a quiet January, hasn't it? Aside from like world events going absolutely psycho. Arnold Schwarzenegger got stopped at an airport for having a $10,000 watch. Well, a designer watch, they said, but I think it's the same thing that happened to Tommy Tallarico, where you can't enter a country with more than $10,000 of goods, or cash on you, actually, was the rule. I don't know what that means for like fancy watches and stuff, but you got to declare it, right? And he didn't declare it, and then when questioned about it, he was like, no, we have less than that because we split it up amongst all of us, which is turbo illegal. Skirting around the laws is actually pretty illegal, turns out. I gotta think of what to do with this stuff. Like double-sided tape. It's pretty much what I was doing before. If I want to just leave this alone and put like a front piece on it, just put like something to give me a boundary there. And I could still use tape and just have a flat thing that'll take the tape. I wanted to actually have plastic though, with like ridges in it that'll hold this. But having a bar in the middle of it doesn't really work. I could give them little, they could slide in. If I printed like a top piece, I could have them slide in, but I don't want to have the radio board on top, or sorry, the speed controller on top of the radio, because the radio needs open sky. That needs to be able to communicate. And I want to see the LEDs too. We should get started. It's only been 36 minutes, but I'm like, I don't know why my brain has been so smooth lately. I don't have much to talk about. I think it's mainly just because we were in snowstorm mode here, and I don't have a rock crawler RC car. I have an on-road, super brutally fast RC car, which is fun, but it's not great when it rains for a week and then it snows for a week. And we got another snow tomorrow. We're going to get 3 more inches over here, which I've been asking for it. This is all my fault. I have been repeatedly and loudly saying that, hey, it would be really cool if we had a snowstorm because we haven't had one in a while. So we broke our 3-year streak, and I have summer tires on my car. I need to switch my rims out. I'm not going to be able to do that it's until after it snows. Is it going to warm up again after it snows? Because this is one of those Arctic blasts where because of whatever the hell we've done to this planet, the Gulf Stream is not as strong, and so we're able to have this inversion of weather patterns, which brings Arctic air down here. And so it's like a typical winter, except that it's a bit more apocalyptic. There's much colder temperatures, and we do that here in Pennsylvania. We know snow here. We're not unfamiliar with it. It's just the patterns have gotten more aggressive. But anyway, we're going to have another 3 inches. And then my question is, after that, is our topsy-turvy, wackadoodle weather system going to then reject all of the cold air and go back to being in the 70s? In which case, my snow tires are not going to be happy. Well, at least I won't have the bald spot on the one. When I was fixing the traction control system, I tried to take it on a skid, and it unfortunately skid a little too good on one wheel. We need a northern border scarf. What's that? Northern border scarf. I heard a lot of talk about how to dress warm, because like Alberta's at like -40°C. It's at the meeting point of Celsius and Fahrenheit, and there was a picture of somebody holding a wine glass that had liquid propane in it, and it was just stable. That's creepy. That's super creepy. But yeah, keeping warm up there is like an entirely different animal. We would go to New Hampshire during the summers and some winters. We'd go there for like Christmas, and of course the snow pile on the side of the roads is like 4 or 5 feet. That got cold. You learn how to dress up in layers. But the Texas getting all this super duper cold weather patterns and stuff, they're in trouble because they do not know how to dress warm. You can't just put on a big warm coat that seals everything in, because then you sweat, and that sweat is going to kill you. It's gonna make you much colder. You need to wick the sweat away from the skin. You need wool stuff, and of course layers, and then an outer shell that's water resistant. I need to get my scarf out, and so I can actually use it. Our weather is mostly just warming up. Yeah, I don't know what ours is doing. Dewey was saying earlier in the Discord that his is just like metronoming from cold to warm. It's like 30s to 70s, 30s to 70s Fahrenheit. Negative 23 F wind chill. I think we got to like -1 to 5. I'm not sure what the wind chill estimate was. I'm gonna burp. It makes the willow walks a little bit interesting. But I mean, it used to get cold here. It used to get cold. I don't know if global warming is just perpetuated by people who hate snow. Well, shouldn't call it global warming. It's climate change. Because calling it global warming is disingenuous. Because what we're getting is climate change, and really, really stupid people, like really genuinely stupid people, are going, it's cold. What happened to your global warming? And you're like, shut the fuck up. Like, you know you're being disingenuous. These are parts, by the way, some of these parts up here are parts for a different synthesizer module. They're a digital one that uses ESP32. There's a YouTuber who does several things like this, and they seem like something that I could potentially manage in 1 or 2 streams. I always say one stream. It always looks like one stream, but these are perforated prototyping boards with all the amps on it, and they have an ESP32 that hooks up to it. And while I could copy their design directly, I'd have to print the front panel for it and everything. I will make one of these. It looks very interesting, but you know, I'm gonna turn up the persistence on comments on the Social Stream Ninja. Don't mind the milder winters, to be honest, but the super hot summers, yeah, the super hot summers are, I'm not a fan. As somebody who has the body weight that I do, which I gotta get better at getting rid of it. It's not fun. All right, I gotta look at the Stream Deck, and I have to update the Stream Deck, or else the changes that I make will never stick. So I'm going over here. You guys can do this with me. It's not like any of this stuff is secret. Let's see, because the Social Stream Ninja takes advantage of your login already. It uses the popped out windows. Hirsute. There's a word I haven't seen in a while. Yeah. I'm looking, so the reason, God, I'm so self-conscious because I've been doing all the video editing, and I just did the 8-hour My Summer Car video, which for some reason is blocked in certain regions. Look at this crap. Hold on, look at this crap. Partially blocked. Oops, no, I don't want to reschedule it. Apricots from Bicep. No impact, it's fine. Amazingly, it doesn't matter, doesn't matter. Ode to Joy excerpt from Symphony No. 9. Sir George Sotty. When did I play that? Blocked in some territories on behalf of Sony Classical. Once again, it's Sony. Any of the crap that like you really are not having a good time with on the internet, Sony. So what in the world? When did I play that? 7:19 to 9:19. That's like the beginning of stream. That's when I was introing. I don't understand. So some regions might not. Hey, if you don't see this movie, the force feedback wheel on February 5th, let me know. I would love to know what territories this crap is blocked in. Would love to know. All right, social stream. I need the persistence of comments a little longer. So I'm going to the web pages dialog. All right, somewhere in this URL is a time. Chart time 100. Yeah, I think chart time. Oh, did it say it was blocked in Russia? No love lost, I guess. Not that I mind my any Russian viewers. I don't think I have a lot. All right, double the time. I think that's what I need. Let me go look again and see that it's blocked in Russia. And then I'll do this here. All right, that should stick around a little longer on this one. There we go, look for the thumbs up. It should be double the amount of time. I think it is. I didn't time it before. I don't actually know. I don't have a frame of reference for this actually. Those are sticking around for a while though. I think that'll be better. Okay, so now we're going to here. Yeah, I want them to stick around a little bit because chat gets kind of slow. Some countries or regions. Go to this, see details. Copyright. Oh, there it is. Yeah, that's the list. Sorry, I didn't even read the last line. Oh, I'm dumb. So it's blocked in Russia because Ode to Joy from Sony is not allowed without them taking all of my money or something like that. I'm not going to be able to monetize any of this stuff. I mean, I know we got like a lot of views from some of this stuff. I got like 500 and 400 views. I'm super duper proud of that. I think that's amazing. I don't really know how YouTube works. I know a lot of the big YouTubers will look down on like a 10,000 view channel. But look, I'll take what I can get. We're slowly growing this channel. Hopefully by the time I'm able to monetize, I will have gotten my shit together and I will actually be able to have some videos that will be released in a state where I won't get a copyright holder, you know, heating up their brand and then poking it into my ass. So, all right, let's get this over here. We're gonna start. Let's start. We're getting into uncomfortable territory for me, which is social relationships. No, I mean, we're getting into uncomfortable territory. What I am doing. Well, I've got this model of the RC car, and we're at a point where I could do sort of a final thrust of effort in order to make this plate here that's going to hold all of my electronics, and then things will be pretty good. I'll have a pretty fast RC car, and all. That's not good enough. It's not good enough. I can't just leave it at that. We need to do something weird and cool. So what I have decided to do, at least, is do an attempt at this. There's some reasons that this is actually kind of in the way. I gotta move that down. Some reasons why I think this might not actually work, but it is something that's not really a buzzword, but it's a feature that people are interested in, which is generative design. What that means is that you set, oh my God, I almost killed myself with this little lamp here. You set some rules for the solids. I hate to just keep calling everything solids, but you know, SolidWorks and solid stuff and blah, 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 blah. You set some rules. You have some shapes that need to be preserved. You have boundaries for the design. You have forces that will influence the design, and then you throw it out to the cloud. And the cloud, I guess using probably AI or something like that, will figure out what the structure is supposed to be of your solids in order to hold those forces in and comply to a couple rules, like minimizing the amount of weight or minimizing the amount of flex. I think it would be really, really cool if we were able to make the entire chassis something like that. There's a couple things that we need before we do that. We can't even get into generative design, I don't think today, because I'm missing a few things. I'm missing a couple things. We need to model the differential, the pinion gear, and question mark. Yeah, there's a couple things that I need. Oops, sorry. There's a couple things that I need in this model that will set the boundaries of what the mono chassis is going to look like. So we need to make a boundary around the drive shaft. We need to make a plate that needs to be preserved for the motor. We need a differential in here with a pinion gear because those both have bearings that need to be held on. We need to put the rear, toe-in adjust into its own thing. Basically, we need to take this distance and put it off of this and have like an attachment point for a ball joint, which I've already modeled. I just don't know where the attachment point's going to be. It'll improve the overall RC car. I also have absolutely no idea what would happen with the electronics in the generative design. I might choose to ignore them and leave them alone and just wait until I've got something that's creating a viable frame for the car. This might fail. This might not work at all. But I have a feeling. I figure we'll do like a couple doors that bolt on from below, and maybe that will allow everything to kind of design its own shell where it can. I guess. I don't know. I may have to project these holes into sketches. I guess I can just make a sketch off of the bottom and extrude up from that, and that'll create, because I want this to all be 3D printed. So I figure what it'll be is like a door that bolts from below, and then the entire rest of the frame is just sort of this continuous generative thing. The problem that I have with that is that this is not a lot of space to operate in. It's very, very little space indeed. It's like, do you need all of this? We could, well, maybe I'll try to do that. So generative design needs like a solid. So we'll probably extrude the solid from this shape, and I'll probably cut off these end posts just for the sake of trying something. And then I'll have to make cutouts for the space that the steering bars take up, because this is an uneven amount of space that moves around, and this moves forwards. The motor's probably going to have to insert from below and have just like an opening where it goes in. How am I? Typical streamer reads the first third. I'm under an obligation to keep things exciting and interesting, and I'm not good at that. I'm an engineer. I can build a circuit, and the way that I build a circuit is through mental attrition, by simply being so stubborn and adamant about finishing the design. This is the same way I am with games. If there is a task that is repetitive and boring, I will do it in the interest of the payoff. It's why JRPGs are like impossible for me to. I can't do it. I can't do JRPGs because I'm like, if I'm at a high level, I'll breeze through this. Enter 5 hours of me doing low level grinding, right? Just use AI to automatically make the circuit. Huh? I mean, that's like a fundamental part. That's been a fundamental part of making electronics for decades. The Garden of Banban, is that what you're trying to? I'm not going to play that game. I'm not going to play that game. Yeah, AI circuits have been around for a while. The big companies were the ones that were doing it, because circuits are much easier for AI than like a language model, because there's certain, you're doing certain paths, you're following certain rules, and you just iterate through until you find the best. It's one of those things that, like, we were talking about AI when I was in my co-op job. Like, it's been around. But that was like the big expensive circuit things. Those are the big expensive ones. It's just through simplicity, yeah. Auto generation. All right, we're not abandoning this because I'm probably going to have to come back to this. Although one of the things that pisses me off the most about this is this right here. The 3D printed part that I made, while very, very clever and very, very useful in an accident, is a liability because it wobbles. And because it wobbles, and it might not be as much of a big deal, but when you're going super duper duper fast in one of these things, having that little bit of wobble right there is not good. And I would love to tighten that up. And I think the best way to tighten up something like that is to put two. Yeah, this one's actually needs to be replaced. Look at that. That ain't right. That ain't my camber. Holy crap. So yeah, what I would think a good solution would be is to take another A-arm and make this a little bit more of a predictable suspension. I won't really get the adjustment. I won't be able to adjust toe-in. It'll just be a flat wheel straight up. Toe-in would probably be kind of useful on these specific wheels, unless I move the attachment point in a little bit, which I have the control to be able to do that with this. But I think what I'll do is I'll just use the same A-arm up top, and then we'll have an even suspension travel. And then at a later date, I can figure out what I'm doing about springing the up and down, making it actually have a suspension. Because this is like, there's like nothing. There's like a millimeter. That's not doing anything for me. I might as well lock the wheels, because that little amount of travel is on, like, it's way smaller than a pebble. And so when I was doing the high-speed runs, I'd hit something and the thing would still just go blah and go way way up in the air and stuff. So I love the carbon fiber. I think that's amazing. I'm not abandoning this, but I would love to see if I can do generative design and put two A-arms on it so that the wheel, you know, bumps properly and it's a little bit more stable. I was dealing with steering issues too, where this would get worn up here, and so the model wouldn't be able to go left fast enough. What is the speed world record on one of these? Because I don't think this motor's doing it, but it sure is faster than I can drive this thing. Also, I mean, you know, why wouldn't you go to a different chassis? It's like 220. Oh man, I don't even know. Yeah, like a different chassis with slightly different suspension dynamics. There's all kinds of like weird, expensive suspension stuff. Oh, this is like a big remote control car. Oh no, yeah, this won't. This thing at whatever speed I've been getting to, which is unmeasured, I need to measure it. Whatever speed I've been getting to, it's like on a sheet of glass. And while these helped a little bit more, the novelty tires helped it a little bit more, it still eventually becomes a big sheet of glass and things are just sliding around. So, okay, so we gotta do the low level stuff. I need to make a differential and I need to make a pinion gear, because all of this stuff is not modeled. All the internal stuff to the rear of the RC car is not modeled, and these are the primary, like these are very important to the operation of everything. I need to have something that supports 1, 2, 3, and I guess bolts in from below and allows the pinion to, or allows the differential to be inserted basically into the model. So we need something with clearance, I guess, all the way out to the end of this thing, so that I can unbolt. Well, actually, no, it doesn't need to be all the way out. I think it does, actually. I think it does. Yeah, because I need these two bearings supported, and they need to have like a thing there to hold it in. The closer I look at this, the worse I'm feeling about whether or not generative design is actually going to be able to make me something on this that is viable and certainly lighter than what I already have. I don't know. I'm starting to have my doubts. I can't even imagine operating an RC car at 220 miles an hour. That is crazy. Because like all the physics are different, right? I mean, I guess you're getting downforce and you're I don't know. We're just having fun with this, you know, everybody's learning, I hope. So I started a second model. We can come back to this one if we get our brains completely blasted today. What? The wheels breaking apart? They just use metal wheels? I would like it if I could, you know, even if I just make my own bell housing, I would like this, because this is going to be so much more stable of a suspension system. I could always do like a push rod from down here and bring it up top. Bring it up, putting generative design in the title has somewhat pigeonholed me into having to do this, hasn't it? Let's get started on the differential. So in the WL Toys folder, I have all of the WL specific stuff, which includes that differential. I don't have a differential in here. I was looking on GrabCAD, because that's always my step one, looking on GrabCAD, and I found this, which looks very familiar, but I think this is like 1/10 scale. I don't think this is the right thing. Notice how the two little attachments on the ends are metal. Because yeah, where's the diff? Where's the diff? Where did it go? Is it safe? Oh, it's right in front of me. I can't see it. It's blended in. Certainly the gear housing is different, so it does look very similar. Should we get this part and see if we can modify it in order to fit properly? It's probably a completely different scale, but like push comes to shove, I just shorten this a little bit and it matches this thing. Unless there's some fundamental difference here. Well, yeah, that would need a little help. Let's try it. Let's try it, because it'll save us a little bit of time if we're able to get this part. Where's the... Oh, this is like a sub window? Yeah, there we go. Okay. Download the files. Show me in the folder, and I'll open up 360. The folder's way over there. I'm gonna kill my neck craning it all the way around. All right, so let's extract it, and then we'll get our own No, we'll actually upload it and then find, we got a SLD PRT, we got a step file, and we have a PNG. Which one is better to use, the solid part or the step? I guess I'm going to use the solid part, SLD PRT. Sumo. I wonder if those, I'll bet you that the 3D printed wheels that I made, the first thing they do is break. They'll probably take an axle with them too when they break. Waiting on the thing. Oh, there it is. Sumo RC differential. Let's see what we got here. So the solid part does not have, whoa. Huh, it's tapered like that. It doesn't have, what do you call it? Any appearance stuff done to it. Maybe the step file is what we want. Oh, the step file is going to have all the steps. The actual steps in the step file. Well, let's just take like an initial measurement. Let's see what the diameter of this is. Inches? What kind of a hedonistic freaking measurement system are you people up to in here? This is ridiculous. Why would you do this to yourself? I just have pity for you. Millimeter. Well, of course, it's a weird number, but 10 point, oh no, it's not. It's 10.033. Hey, guess what? If your fundamental units are in millimeters for the design of your part, maybe you should reverse engineer it in millimeters. It might save you a little bit of 0.033 drama. All right, 10 millimeter. Well, how'd he do? This is the size. Imagine using just 10. I know, I need that 3 on there for baggage. This, what? Sumo RC? Do they make 1/24ths? 3219. We'll double check, but I don't think I'm going to use this design. No. 3219. 38. I mean, that's only a little bit longer, but that is about that size. Yeah, I'm definitely getting a 32 on this. Huh. And that has metal on the ends, and it's got, what's the distance between the bearings? Bonk. Bonk to bonk is, could you imagine doing this in inch? Crazy. Now this one's a kind of a weirdly specific number. 21, what was that again? 21,336. It is just dead on 20. So 1.336 longer. That's a strange one. I wonder if that comes out of the wash if I make that the main drive a little shorter. We're gonna make something similar, but I'm not gonna use this. I don't know how they made those gears though. We know how to. We can make gears though. So let's do our own and let's save it as. I don't even know who made this differential. Just call it a WL diff. That's crazy. I didn't think that would have been 1/24 scale. I thought that would have been like a 1/10 or something. They're more popular. We need to start with a gear, it seems. Start with a gear, and then we've got a bunch of distances for cylinders. I mean, I could do a sketch. There's a gear making tool. We need to look at the gear making tools because I haven't done that in a long time. How do I get to it? Add-ins, scripts, and add-ins. Oh boy. Now we're in for it. Nothing happened when I hit the button. Oh, it's all the way over here. It opened it on a much different screen. So what we're doing now is we are setting up all of the important stuff that we need to tell generative design to design around. This is a very necessary step, and it's going to take us some time. The question that I have, and the big worry about this, is that it is possible that there's not enough stuff to make an interesting generative design. I want spider webs, but I don't know if that's going to work. Oh yeah, I got GitHub Diffusion 360. That's a way to export everything. bolt, bottle, graphics, bomb, spline, intersections, spur gear. There's two. There's a Python and a C. Try this one. Boop. Cool, cool. Nothing happened. Okay, nothing happened. Did it do anything? No. Okay, let's try the other one. Spur gear. There it is. Metric. Okay, pressure angle, module, number of teeth, backlash, root fillet radius, rear hole diameter, pitch diameter. How do I tell it that I want it to be on the front face, though? This is spur gear. Maybe there's a different gear that we need. We can look at the App Store. We can see if there's a good App Store, because like this one seems to have found something to make this. I don't think they just repeated a pattern throughout the... What is that doing there? Why are you like this? Huh. Maybe they did something like that. That seems a little odd, though. And then they also did this. The taper in. Strange. Well, let's see if we can find a gear tool in their App Store that does... What kind of gear is that called? Hold on. Listen, I'm not a mechanical engineer. I'm barely even an electrical engineer. I've been paid for like one job of electrical engineering. Oh, look at you, smarty pants, Mr. Mechanical fucker. You know exactly what you're talking about. Gear types. You can't stop me. I'm still going to search the dumbest thing ever. I can't be stopped. I'm going to search the dumbest thing ever. There's nothing any of you can do about it. Yes, yes. Worm, straight bevel, helical, spur, rack, internal, screw, spiral bevel, worm, wheel, gear coupling, pull, and ratchet. See, that's that word that I use all the time. I'm gonna do my best not to backseat on this one. You don't have to. You can backseat. I'll be all right. Worm. Excalibur. Man, I remember when those... I wonder how much... Was that Geometry Dash? No, it's Hyperhex. Huh. So it's a... How's that a straight bevel gear? Oh, because that one's spiral. It's actually the... But it's like an angled bevel. Okay, so bevel is the gear type I think that we're looking for, right? As you have correctly stated. All of the bevels are beveled, though. They're not like on a flat plane. That's a spiral bevel. Helical. I don't know if that's an important detail or not. Something in my head is saying that it is, because every time we see a bevel, it's at a 45-degree angle. Maybe it's a bevel at a straight angle, a flat bevel or something. Call me crazy. I just thought that that was a detail that I should think about. Rack and pinion. All right, so we'll go with the premise. We need a bevel gear. We either need to invent it, or we need to get like a utility that's going to let us do that, or an add-in rather. So let's. Oh wait, no, we need to look for add-ins. App Store. It opened all the way over there for some reason. Nice, thanks. Look at this. They're just flexing all the gears that they have available to them. Joiner CAD, blah, 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 3D PDF, BOM. GF Gear Generator, basic gear design application for enthusiasts and professionals alike. Free. That's what I like to see. It says FM gears and GF gears. Minimalistic gear design application is such as designed to make the following the metric module DIN standard series. Irregardless, they use the wrong word. It's made for everyone, no matter your amount of knowledge. If you have an engineering background, includes 11 different types of gears. Spur, double helical, 90-degree bevel. There we go. Although, are we looking for 90? We're looking for like flat. We'll see. This seems like it might have the right thing. Profile shifted spur. See, that said 90-degree bevel. They didn't say flat bevel. We need like 180 degree? I don't even know. 0 degree? Well, I guess we could try it. Damn it. Okay, that's going in a different window. I'm already logged into Fusion. Why would you ask for this? Ah, I need the 6-digit code. You guys are not going to get any of my information today. I've been hacked too many times. What the hell am I doing over here? What am I clicking on? I'm looking for that, and I'm looking for that one, which is... Oh crap, it just changed. It just changed. What am I going to do? 69420. There we go. Okay, cool. Get out of this app so it doesn't show by accident, and then I can go back to download it, and I can give you guys this view. Okay. I've done it. I've done it. Run. Install. I thought I had something like this installed. Maybe I passed over the gear simulation things. Because we made that other gear using the gear tool that I had. Ah! Close. All right, screw documentation. Let's just take a look at this thing. Oh, wait, no, not the App Store again. Close that. Add-ins? Scripts and add-ins? Huh? It was like something or other GS. Oh, here we go. My add-ins. Oh, I forgot about this. 100K garages. Fusion filler. GF gear creator. And we got the Voronoi. Trace parts. I don't remember some of these that I added. Yeah, I added some stuff just perusing the forum or the App Store. Okay, GF gear creator. Gear creator. Oh, I remember this one. Wait, they said they had a bunch of different types of gear. Oh, here we go. Worm gear drive, internal spur, non-standard internal spur, simple double internal helical. Simple double non-standard internal helical. What? Double. Hold on. I gotta Google this, man. Did you mean double internal non? Yes, I did. Internal gear. Is that what? I think we're an internal gear. Hold on. Let's look. Screw gear. I'm using belts. That's not internal gear like that. This kid does not know the type of technology that's going into his... Huh? English language failing descriptions. Who would have thought? No, I'm not going to make her print my own gears. We're modeling the differential that I have. This is this thing, which has the gear surface on it. That's the only gear that we need from that. I also need to do the spur gear that goes to the drive shaft. But we know that's easy. So it's not internal. This would be a bevel, but it would be a different kind of bevel. So double helical, no. Spur, non-standard helical. Internal spur would be internal, right? Yeah. Profile shifted spur, I'm not sure. It would be like a gear rack, but wrapped around. Or like a 90-degree internal. No, that doesn't. What is that? Oh, what does it mean? What does it mean? Hold on. I'm getting stuck in just dumb stuff like this, but that's what we're here for, right? That's why we do this stream. it would be like a sprockets and cogs. Sprockets and cogs indeed. What would that be called? Be a straight cut. It'd be like a 90-degree bevel. No, 90-degree bevel is the 45-degree thing. So it would be like a, unless in the bevel gear. Hold on, do we get the angle in the bevel gear? This one says 90-degree bevel. Pressure angle for, no, that's about how they mesh. Fast compute, number of teeth per pinion. So that's going to make both gears, but we want a straight cut pinion. Huh. If we wanted to deal with thrust bearings, it would be fun to redesign this to not use straight cut gears so everything is nice and quiet. I'm not going to get that nerdy with it though. I want to. There, you, what are you? Spur. Spur gear. Spur and pinion. Oh, but what's the other gear? Wait a second. You're lying to me. That one's the spur gear. What is that one? Teeth protruding out from perimeter, mounted parallel axis, transfer movement between two parallel shafts, and no thrust force is generated. That's the important part, is no thrust force. You call that a pinion, you call this a spur. What is this? You know, I used to find a lot of these things in toys in the 80s. Or 90s, probably, most likely. I used to find a lot of this specific plastic gear. Which I guess this is probably derivative of. Spur. Module, number of teeth, height, pressure angle. I don't have any way to tell it that I want like a 90-degree spur. Curse you! So back to the App Store. Although we still don't know the specific engineering term. This is what's kind of holding us up here. They've displayed the exact gear that I need, but there is another term for it. It is a type of spur, I suppose. A lot of these websites just want your clicks, huh? Spur gear, maybe types. I'm trying to scroll up, but there's very little space on Google Images where you can actually get the scroll up arrow. There we go. Spur gear types. None of y'all are what I'm looking for. Now we can make spur gears all day. That's easy for us to do. This is a different type of gear, I suppose. And what I could do is just try to model it. Rosettes. Let me try that. I think that one spurs from it. Spur. Yeah, that's interesting. What the hell is... That seems like... Oh, small rig? Yeah, so this is like an industry term. Maybe. I don't know. It's just when camera gear comes up from a search for a specific name. Does a spur gear go radially like that from the... I don't know. Spur. Does nobody care about engineering anymore? Nobody has these kinds of gears in mind. We're forced to sit here and exist in sort of the negative space of the progress of technology. Long since has man moved on from this type of gear. I'm not trying to do anything but model what already exists inside of this differential. I'm trying to model this part right here. This part is designed to go into this housing and have this spur gear interact with the differential. I want a tool that's making me this part, the differential gear right there. And then I can extrude a whole bunch of tubes from it in order to get everybody, you know, in the right size delineation so that I can tell the CAD software to make spider webs around it. It's not an uncommon type of gear, and rosettes got very close. It's weird that in camera equipment they keep those gears moving all the way to the center. I wonder if they just have to deal with smaller, smoother gears and more weight or something like that. Just have more to mesh. Would it be easier to model the trapezoid and circular pattern? Possibly. I could meet, I don't know if they meet all in the middle. They probably do. Then I would have them come out at an angle. It's not a trapezoid. Oh yeah, that's open in Fusion. What's that thing cost? 18 bucks. Whoever was modeling this made the teeth uniform. I suppose you get a center line on it, and then you go distance above. I don't know. Probably not doing a hardcore engineering model of it. Sometimes these models have all the different parts inside of it too. You've got like individual balls in your ball differential. So like internal spur, no. Non-standard internal spur. Nah. Radial thickness. I don't think that's right. Face gear. Wasn't that a member of the A-team? Aha! Face gear. Face gear is what I wear at night in order to sleep properly. Okay, let's see here. I've never heard of these. Well, it looks like you're right. I've seen them all over the place. So I need a face gear. I hope this doesn't get us into like specialty apps that you have to pay for. So I ain't paying for shit. I need a face gear. SVG vector exporter for shaper origin. No. Helical gear plus. Oh my god. None of those are the gear we need. None of them are what we need. Straight helical and herringbone external, internal, and rack gears. Man, people love their gears, don't they? Gears are rough. There's so many things for gear. Oh my god. Look at these things. Labbers spur gears. Oh my god. Herringbone and spurs. Nope. Helical double helix herringbone spur with or without. No, where's my face gear? Gear train maker. Rack gear generator. Planet is 20 bucks. Face gear. Hello. Why do you guys come up when I look up face gear? Worm gear drive. Helical and straight hobbed face. Manually modeling gears is a huge pain in the ass. Yeah. Even just figuring out what our gears are and getting the right, like, numbery stuff is a chore. Hobbed face worm gear. I can't believe this is what we're doing. Hobbed face worm gear. Making a worm gear. No, I want to see what a hob-faced worm gear is. That's not what we're doing. Double enveloping worm. Single enveloping worm. Worm. So that's hobbed when it's cut. That's like one of those, that's like a big gear cutter. In fact, That's what you do with a hobbed gear cutter. The answer was here all along. So that's not what we need. That's just why this came up in a search. Surface. Okay. I might have to, like, make this. Pitched circles in meshing relationship causes the spur gears to be rotated and positioned. This is an add-in for Autodesk Fusion 360, selecting multiple pitch circles. Places spur gears at the location of those pitch circles. It automatically meshes the spur gears together. That's cool. I'm not gonna get it, but that's a cool tool. FM gears, creating spur and rack, but then there's no mention of face gear. I can't. Why doesn't this come up? Maybe this is why we don't see them nowadays. So this had 2 results. Helical gear generator wasn't it. This is the one we have. Face, hobbed face. Sorry, this one. Face. Faces. Surface. Surface. Okay, so we're on our own. We got to use a circular pattern in order to make this thing. How in the hell is that going to work? Well, we got to figure out how many teeth there are, and then we can just follow the lead of this. See, they did a thing where they tapered this inward, and we don't have that on ours. Ours is like a typical face gear where it's just like a flat thing. So I have to make the silly little trapezoid bar and have it repeat around the circle with the distances correct. Ay, ay. And then they didn't like rose it. They kept it like this. What does a real one look like? Hold on. Need the gear's pitch diameter to align for proper meshing. Okay, hold on. Where's my search window? Here we go. Face gear. Let's take a look at a face gear. Can't quite see in that one. Planetary mechanism with face gear. Let's see. Gotta wear my orthodontic face gear. Here we go. Generating hobbing. This is like a research paper. Hold on, get me out of here. Yeah, no bevel on the differential. What's up, fast you guys? Blah 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 blah. Not a lot of exciting stuff has happened here over the break. I tried to like talk about what I was doing in the like in between streams. I'm like, I don't have anything. I don't know what I did. What is up with those teeth? Look at that. They're like pointed inward, probably to accommodate for the teeth of this thing. What does the real thing have? So I want to use generative design, and I'm gonna keep like recapping. I want to use generative design. I don't know the first thing about what I'm doing, and in order to even just start with generative design, we need to tell the software what the do's and don'ts are. So I need to figure out these parts that I've been avoiding designing. Everything's falling apart. I've been uploading to YouTube, and apparently one of my videos was blocked in Russia because I used Sony's version of Symphony No. 9, which I don't remember doing. That was during the 8-hour live stream where I first tested the wheel. You were there, Gonad. Whoa, what happened to that one? Oh, it looks like it got messed up. What does the profile of these gear teeth look like? I'm trying to get light on this so we can actually see. How about the lighter colored ones? These are terrible differentials. I think they are fixed. I don't think there are balls in these. These are the ones that come with the WL Toys kit. WL Toys kit has terrible. The other day I searched Oh Bother on YouTube and couldn't find anything. Oh, probably here. VOD. There you go. That's the link. That's the VOD channel. I made a separate channel because it's going to be really spammy for a while. You know, while I establish all of my videos on there. And all this work that I'm doing to get this sort of like the times that things happen will allow me to go back in and edit and do cool stuff there. Listen to Yo Yo Ma playing Box Cello Suite #1 yesterday. Unrelated, but semi-related. I have no reaction for that at all. I don't know why Symphony Number 9 even played on my stream. But it blocked my content that content in Russia. So I apologize to any Russian viewers, but eventually I'll be able to cut together the steering wheel project and you'll be able to see some of the fun parts. There were some fun crashes in that stream. These look like I can't even tell, actually. They look like they radiate out from a center. They actually look like they radiate out from a center. Meanwhile, these don't. These do the opposite. Unless we're in some kind of a viewpoint that's, I think we are an orthographical viewpoint. Why would they be larger there and then smaller as it goes away? Maybe because this is at an angle? That's all I can think of. But radiating out from the center in order to get the dimensions that we want. And we need 4 lines in order to do that. And I need a radius that's outside of the circle because I want the circle to cut it away. I gotta think about that. I don't know what that means for making the spur gear too, because there's specific numbers that we need to get for the spur gear. This is designed by repeating the shape over and over again, and this is actually not how they are. They are supposed to taper in towards the center. And so the distances would be consistent, although they would all be triangles. Doesn't that not mesh with the gear tooth? This is complicated. Gears are complicated. They're oddly complicated. And measuring this is going to be obnoxious because these are very small teats. They come to a point. They come to a point. So we have triangular pitch. Well, it's that. How many teeth do we have? Dear God. Let's see. We gotta count from like a landmark. That's a pretty good landmark right there. What are we counting as teeth? I don't think the triangles are teeth. I think the indentations are teeth. So yeah, we'll start. How many of those are there? Is there only one notch? Tell me there's only one notch. This is an actual ball differential, so it's pretty nice to have. It can be loosened up and actually do its job. Although at some point when you're driving the car, it will just decide to bind and then everything goes to crap. Okay, so we only have one of these marks on the radius. That's gonna help us a lot. That's not a good way to count. I keep blocking my light because my hand has to get in here too. Other microscopes don't have to deal with this crap. Open that up a little bit more. I really need this light to be in a better position. Hold on. This guy moves away. This comes in here. Tighten that up. Let's get a gear tooth count. 1, 2, 3. You're sitting here with me for this whole thing. 4, 5, 6, 7, 8, 9. There are tools for doing this. 10, 11, 12, 13, 14, 15, 16, 17, 18. Are we there yet? 19. It's binding a little bit. 20, 21, 22. Ooh. 23, 24, 25, 26, 27, 28 teeth. Is that correct? That's 28 to get to the mark. There's only one mark? Only one mark. 28 teeth. Nope. 28. 28. 28. And the square cut is the opposite direction. So how am I going to do that? Okay. You guys remember? I'm gonna put 28 into a browsing window over here. So just have that number hanging out. Okay. So over here, I guess we can start our model. And then I can figure out what the sketch is going to look like. So the main gear is going to be on this plane. And I guess we'll center it around origin. So we need our outer diameter of the differential. So let me measure that. 15 millimeters. Oh, all these metric numbers are just so even. Oh yeah, I have Notepad open in order to save all of my video descriptions, because if anything goes wrong with either the uploading or the encoding of the video, YouTube is like, delete it, delete the whole thing, erase it from existence. And also, your description, you can't get to it anymore. So I've had to save that in a separate file. Every time I finish figuring out what the description is, I have to save it, and then I can let the thing do its work. 15. I'm not going to make the 15 joke. I'm not going to do, oh. Damn it, I just did it. I can't help it. I can't help it. My jokes are so stupid. The thickness of this sickness is, it wants me to say 2.25, like exactly. I guess I'll do that. So 2.25. I guess I'll do multiple sketches, yeah. And then I need something that I'm going to cut out. How am I going to do that? It's not a joke, it's a reference. Yeah, I guess. I suppose so. I do a pattern and I cut it out of the middle and then I repeat it over that. Or I do a pattern and I extrude it into the center, but it won't taper inward when I do that. Basically what we have are like spikes that are going to go inward because our gears are square on the outside, I guess. They're like spikes that go inward. How do I model that? I think I cut it out of a ring. I think I cut them out of a ring because the consistent pattern, like I could make the triangle or the trapezoid pattern, and then I can wrap it around this, which is really intense to get it to match up again. How do I do that? How do I do that? I can make one of the triangles and then I can repeat it around the radius. Maybe that's probably the way that I need to do it. So the final distance on this thing for each of these teeths is, this is not an adequate measuring device for this. Oh boy, that's not really going to work. 0.8, I don't think so. I go from here. It's not 1 millimeter, I'll give you that. I mean, I guess I can say 0.9. What was I going to do again? I was going to make the triangle by going inwards, but the projection is weird though. If I make 2 0.9s and I wrap them and I make one spike, yeah, there's a whole subset of tools that are designed for measuring gears. I don't have any of them, and I certainly don't have them on this scale. What is the height of the teeth? Hold on, 3.11. So that would be, I mean, this is 2.2 and we got to get to 3.1. But hold on, I'm not doing this right. I need two extrusions that are going to intersect with one another. Wait, posted the comment from a YouTube? Hold on a minute. We're looking for a face gear is what we're looking for. If I take a straight bevel gear and I cut out the things that are going to make the triangles, I don't know if that'll quite work. I almost need to like machine it. Like this is wrong. Although as a shortcut we could do that. But we have like triangular gear teeth, because the square pattern is actually on this surface and it's wrapped around. I'm just thinking. I gotta think for a second here. This is gonna break me. If I create a sketch here, yeah, it doesn't let me do that. Create sketch? No. But I can wrap the sketch onto the cylinder, and that'll let me bevel out a tooth. So if I extrude from here, started object here. Wait, what was this distance again? I'm trying to reconcile this. From here to here is 2.25. 225, and then this is 3 point, I don't want to say 25. 25 is a little loose. 3.2. 22532 is like, is that 1? Am I dumb? My brain doesn't work right. I need a calculator. 3.2 minus 225.95. It's almost a millimeter. So we'll give it 0.95. So extrude this. Did I select it? No, I didn't. This. Start at object. Start here and go. Do I really want that? Wait a minute. 0.95. I want it to be a new body. What happened here? Something happened to my thing. I'm just trying to figure out how I'm going to do this. Really straight from the machine handbook. They say it's a bevel gear with the axis are at 90. Unfortunately, the bevel gear stuff that we found doesn't let us say what angle it is, which would be great if we could. This thing, the bevel gear tool. Oh, I don't want to do. I just want to show the. So, bevel gear. This thing says 90-degree bevel gear, but yeah, we can just give it the module, the units, and the pressure angle. The technical term for the gear that we're trying to make is a face gear. I don't want to have to do the pattern around the entire thing, because you can wrap like a sketch around stuff. Why did that look so weird for a second? Are we in orthographic? No, we're on the right. Just trying to think. Just trying to think. If I measure out the diameter versus the, what is it, the length around the circle, and then, you know, do that math and then make that pattern and sketch around there, I can wrap the pattern around and then extrude it inwards. I don't know if Fusion is going to really kind of not have a good time from that. And let's see, the inner circle on this, we can define this a little better. 2 millimeters. So we want a diameter of 2 millimeters less than the outside. So I'm going to go back into the sketch. Hold on. And that's 0.8, so 13 millimeter. Finish, and I'm going to extrude outer ring, start at the object here, and that's 0.8, well, 95. So that's a weird number. It feels like it's probably 1. And then if I measure this whole thing, no, I want the whole thing. Loop length, 40.841 millimeters. So I'm going to make a new sketch. This is a weird way of doing it. I'm going to go on this plane, and we're going to go and project this line in. Go back to our, well, we're going to have to get the solid out of here. 40 40.841. Body's gone. And then we're going... Actually, wait. I can project both of them. We got that inner line. I'm going to project the outer line. Then we get rid of the body. We go back to our normal view. I'm going to go from, I guess, the center. Do a 3 points rectangle. Doot, doot, out this way. 40.841 will make the print a snowblower attachment for the RC. I've seen stuff like that. That looks really fun. You'd want like 1/8 scale though if you're going to do any meaningful work. And then you're probably going to hurt yourself, because my friend of mine got a snowblower when he got his first house, and he messed up his finger like right away. He's trying to, there was like a blockage, and he put his hand in there to clear it, and it caught his finger, and he's lucky he still has it. So we are creating some kind of a thingy that's going to get spaced out over this distance, and it's going to have 28 elements to it, right? All he can do is make it. It's up to him to not be stupid. That is true. That is true. Spline. No. Polygon. No. We're just doing lines, I guess. Because, yeah, we don't really have rectangles or circles. It's going to be... So what is that going to be like? It's going to be... Hey, Caravos, how's it going? This is, by the way, I don't know anything about how gears are constructed. This is one of those things where I'm just kind of winging it and hoping I get some of this stuff right. So the triangle and the gear face, and then we have something like a 0.9, which could be totally wrong. I don't know how this calculates out. And then we have another angle here that I don't know what it is. Actually, wait, instead of measuring that, I should be measuring the approximate distance of how far around the circle. This is going to be very strangely derived, mostly because I hate math. There's a lot of math in this. No, that's not going to work. If I measure it like that, like 2 millimeters in between, because then we have to wrap it around the circle, and that's where things get mad. It's not like we can unwrap this. That's why we have all of those weird numbers. There's that like gear math here. Look. What is that window? Oh, that's the one with the gear generator on it. Gear modulus calculator. 28. Huh? 1 inch diameter. What? Type external pressure angle. One in 45 degrees. OD reference, pitch diameter, root diameter, addendum, dedendum, working depth, hole depth, circular pitches, tooth thickness, base circle. This is how to cut gears, actually, is what this is. But this stuff is crazy. Gears are wild. Engineers and their math. So what I'm thinking about is how I can make the tooth profile here. It's a relatively simple tooth profile. They're triangles. But I don't know all the distances, and it's very difficult to measure. How'd the fan go? It's on the 3D printer, and I have the tube draped over top of it. But for now, it's just going to kind of sit there. I don't know if I'll need the fan. If we get to generative design on this, if we don't tootle around with this stuff too much, I was hoping we could find a plugin to do this part for us. But if we can get to the generative design, I might need to get that fan working in order to get it to print properly if it has a lot of challenging stuff to print. I really want this to look like your typical generative, here, look, generative design. Generative design. I'm going to work on mounting the electronics normally on my own. It's just I'm not going to be able to race the RC car for a little while. So here's the example that Fusion gives you, where it's 4 posts and then like a hanger, and you give it the amount of force on everything, and it figures out kind of how to put it together. But I want it to look like some kind of a creepy biological thing. I think that would be really cool. I just don't know if we have the space in order for it to do that. I don't know if the RC car is going to really benefit from this, unless we get like a tiny mesh size in it. But I don't know if that's going to work out, given the size of everything. Hey, Pyro, what's up? How did they do this? They probably made their little trapezoid and then cut it on the outside and then just repeated it around the circle. But like, yeah, we got to make a similar diff. I don't know the angles until I put this together. If I go from the center and I repeat it 28 times over the, how do I get rid of this thing? Hold on. There we go. Bouldering. Oh, cool. The number of teeth would be over this distance. So if I use the pattern tool and I do 0.9, 0.45 in this direction. No, if I just do the first tooth right here, hold on. That starts 0.9. Try not to make this hard on myself. 0.9, and then there we go. Create a pattern. And we are going in this direction. And we are going the distance of 4841. And there are 28. It doesn't appear to have done anything. Let's, wait a minute. Ah. So now I can take, I'm gonna have to do this 1,000 times, maybe. I can take a construction line going from here to here, take the center point of it. Oh, there it is. Oh, come on. I hate it when it doesn't give you the 90 degree. What are you doing to me? Oh, it's thinking hard. There's a lot of shapes here. For some reason, Fusion gets very annoyed when you... Come on. See, now this isn't... Ah, jeez. Just keep it like this. There we go. Almost could have broken a leg today, but everything's okay. It was a bit scary. Holy shit. Foot jammed, missed a hold, and fell to the foot still jammed. I've seen some horrible things happen in that situation. Horrible, horrible things on places in the internet that I should not have been. So if I take this and I repeat that all the way down the line, I'm not going to individually draw all of that. Hell no. But I repeat that pattern 28 times. The distance of 4841. Those should all connect. Yes, okay. This is what I'm, uh-oh. What are you doing here? What happened here? Why did some of them not connect? All at ease. I guess I only needed to repeat it 27 times. I could just delete that. Yeah. Everything's broken. Whatever. This is my United States of whatever. Oh, I see. It didn't make this into a... Wait, why was there a break in the line right here? Huh? That's a strange one. Oh, I see. That's the end of the projected line. I see now. Okay, so we've got all these boxed out except for the one on the end, which might be a problem. Might need to actually pull in, might need to repeat the pattern again in order to get one on the end, but let's finish that sketch. And then bring back in our solid. And how do we do the wrapping thing again? Emboss, box, cylinder, torus, sphere, pattern. Pattern on path might have been the way to do it too. Shell, draft, scale, offset, split body. Where did that tool go? We used it in the past. We did, it was like wrap, sheet metal. Not quite. Component, flange, bend. Not quite. We'll get there. I'll figure it out. I have to stand up. We're trying to model some of the pieces that we need in order to do an attempt at a generative design using the 1/24th scale model. I would like it to use 2A arms because that'll be much more stable in terms of the camber. But the amount of material where generative design can actually do its influence is very limited. We need to set up for the model though. Chat's been fine. Everybody's been great. Except for Chester, yeah. I mean, my RC car stuff has been doing better than everything else, so I'm gonna do a little bit more of it before we get back to burn the subs. This is getting out of my skill set, though. How do we do this before? We like coil, torus, sphere, cylinder, box. Nah, thicken. I mean, like pattern on path. The path would be this. But we don't have any bodies to mess with. How does that work? So what if I extrude that 2 millimeters and I do pattern on path, objects this, bodies this. No. Path is here. Distance 40.821. That's not working out. One direction, orientation identical, quantity 28. Yeah, there it is. Perfect. Not quite. Your stuff isn't skill, it's voodoo. Yeah, it seems to be. Suppress. Cancel. Okay, let's get out of that. There was a way to wrap a pattern, and I don't remember what it was. It was like wrap sketch. I think it's in a different, like a different type of construction here. Modify, assemble, configure. Plastic. I don't think it was in plastic specifically. Boss, snap fit, lip and rest. Oh, that's cool. Oh, but you have to unlock those features. Jerks. emboss. Sketch profiles. Yay, I get to click all of these. Sketch wrap is an add-on? Oh no. Well, emboss might do what we're looking for. I remember using emboss for the shifter on the wheel setup. That thing, that shifter right there, that's got a hexagonal pattern cut in it. And we used emboss to do it. Might be missing a tooth. Let's just try it though. Cool, that totally sort of worked. Although 28 doesn't seem to fit for some reason. Oh yeah, that's definitely close. Why is 20... Oh, 26, I'm missing... Well, 2 isn't going to make up for that. That is dangerously close to what we need. How are we missing that many teeth? Did we miscount? 28 is the number that I put in the thing. Let's double check. Let's double count. And then it might just be that my 0.9 is not long enough. But there's no flat face on the top of these. Is the angle too steep? Yeah, that might be it. It might be a larger distance diameter. But this measures up to 15 exactly. All right, so we have an outside feature right here. That's going around. And we're looking to see if maybe there's a feature that I missed. No, that's the only one there. So we're going to recount. We're doing a recount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. 28 teeth. So we're good on that. 28 teeth. So my spacing is maybe wrong. Measure this. 92.248. Ah, that's different. 92.248. Oh, whoops. We want this sketch. It's much longer, and I'm going to go into this and go into the pattern here. That's a little different. Whoa, why is it all broken? Oh, because that was wrong. There's 2 patterns that play here. That's totally, no, that breaks it. Hold on, we're undoing that. That breaks it. Math is hard. Yeah, it is. Right, I only need to extend it by 1, and I don't know what I'm going to do for that. I don't know what I'll do for that. I think I can cheat and get it just right. But the extent, I mean, I have 28 on this, but like this distance... $47.124. That's a little easier. 47.124. That extends that out. That's just like a base. That looks like, yeah. So with 47.124 and 0.9 on the teeth, it's only 28. Yeah, and we don't have to get it perfect. Now that might be 1 millimeter. Let's get the body out of here. Get out of here. What was that again? 47.124? Yeah, 47.124. So the extent for this one, well, for them both, is 47124. Where did that other number come from? That number came out of nowhere. 47124, 28 teeth. Click OK. And then this one, 47124. Click OK. Now I'm going to cheat. I'm going to go all the way to the end. And while that should meet up, I actually need an entire shape on the end. So actually what I'll just do, I'll just take these. See if I can't. No, that was the wrong thing. Hold on. It's not going to let me do that. Damn it. Now I have a line here. But it's free. I'll just take it over to here. Oh no, that extended it weird. Here, view it from here. There. That made the cutout solid. There's the sketch. Okay, so now I need to do what I did before, which is emboss. Emboss. Doot, 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 doot. Doot, doot. So many doots. Doot, 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 doot. Doot, 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 doot. I guess we figured it out. It's a little sloppy, but that's okay. It's just, I don't know why I had to get that right. I really didn't have to get that right. Sketch profiles, create self-intersecting body, adjust depth of the emboss. -2. It doesn't like it because that last one is going to intersect because it's like right on top of the other one. See, that looks like the right thing. It's just, it's off by like a fraction. So I need to take in that little fraction. It'll be kind of a blemish. It will be a blemish. But how much does that intersect? Because I don't know if I need to move that way in. Let's see if we can move it a little bit. So in here, no body. There. I don't know if that'll do it. I don't know if that'll do it. Emboss. I might have tilted it while I was handling it too. Because I didn't, it's not like I measured anything. I wonder if building up the triangles would be more forgiving than you know, cutting the ring. That's probably the way that I should do it, actually, to be honest. Cool, perfect. Bonk. See, now there's going to be like a microscopic blemish on one of these. One of these, yeah, right there. See, that one has just a slightly flatter face right there, just because it couldn't reconcile the circle. Can you not just make one of these embosses and circular pattern it? I don't know how I would do that with cutting it out. I think, you know, I could make the triangle out of a new object, and then I could circular pattern it, and then I could join the two objects together. This is fine. This is fine for the part. We know that there's a blemish, but it's not a big deal. Manufacturing tolerance issue. Because yeah, now I've got a very spiky gear indeed, but it is the one that is on this differential. These are hard to see. And then where's the scope? Oh, good. It's like, it's in the dark. Good. Hold on. Nah. That's decent. They really are just triangles, aren't they? The rest of this I am going to model with solid blocks, except for the dog bone outer piece. We'll have to see if we can find a bearing, but yeah. So that was a lot more difficult than it should have been. But I can now take a third sketch. We can make all the other features of this thing. So we have a wide area, which is 10.8. That's not moving. That's like 10.8 no matter how I measure it. 10.87. Are you going to be printing a gear out? No, this is too small from a printer. If I were doing this, it would not, if I was going to 3D print like all the stuff, this would definitely not be 1/24th scale. 10.87, what is this one? 9.23. Why are these such weird numbers? 923, and then the output 6. Okay, now got those. Now I need to do the distances from either end here. So those are going to be what distance from the back end of the... See, the problem is the back end of this thing is like just barely a shell. It's not really all that well established. It's not easy to measure from. 11.36. Is this live? Yes, you're watching or listening to, however you are consuming this media. This is a live stream. I am sitting in the shop, maybe with an offset of a few seconds. I think there's a little bit of an offset, but doing this right now, and we are muddling our way through designing this thing. Can you print nylon in open air? Does it require an enclosure? I don't know. I don't know those questions. 11.52. I'm going to take it for its word, and I'm going to go 11.52 in this direction. So that'd be 11.52. It's going to eventually form our dog bone. And then there is a... Oh, is that one a different diameter from the one on the other side? 10.3, and this one is 10.8. Oh, are you kidding me? I need another line. I need another line. I need to stop doing the voice where I hold back my vocal cords. Not good for me. This thing, this voice that I do, it's stupid. You and you. Wait, no. Which one was it? Which one was it? Can I label these? 923 is for that longer extrusion on the other side. So 10.4 is that one. Okay. And that goes to an extent of... I can't get a measurement of that one. That's against the teeth. 2.18. Make it 2. Well, the problem is this is where the bearing is set. I'm gonna go to what the calipers say on that one because the bearing sits up against this surface. What software? This software? Sorry, this is pre-recorded, so I can't actually address your questions directly. Your question about Blender will have to be put towards, you know. No, this is Fusion 360, and I had to use the beveling tool in order to create the cutout for the gears. The tool that I downloaded, what is this scene? The tool that I downloaded is a gear tool. It'll be much better for making the spur gears. Blender's more useful in 3D assets Yeah, games and kind of different workflow. Although there's a whole sect of just perverts that create engineering tools in Blender for making 3D parts and stuff. We've run into those in the past, and they're kind of mad 3D parts. They look like they're really well engineered, but they've got all this like sleek angling and stuff going on, and then when you try to like staple their meshes back together, everything starts to fall apart. But apparently you can use Blender for some pretty engineering kind of stuff. Gonad has made his whole apartment or whatever in Blender in order to plan out where furniture is going, which is pretty cool. It's a very useful tool, and it's also very free, and a lot of people are using it, which makes it a very good tool indeed. That makes it a very good tool. I like my tools where a lot of people are doing stuff at the same time. 5.36. What kind of a measurement is that? Extrude? Oh, I need to actually get to the circles. I can't get to the internal parts of the... Okay, so this and this. And where was I measuring from? I was measuring from the actual plane. Yeah, so I need to go this direction, negative 5.36, but Fusion says, wait, there's nothing here. I don't know what's going on. You need to make this visible again. A good way to manage how your tools are stapling things together is to view and unview the bodies of stuff, and then Fusion makes an assumption based on what's present. Next is the 9mm one, and that's going from this to, I can't quite get a good, that's not going to be a very accurate measurement. I think it's 12mm, but there's like a washer in there that I'm hitting up against. It's like 12 1/4, I think. If that's 3.1, it's almost 3.15. Now let me try to get the datum directly from the thing. I mean, that's close to 12. I can't quite get a decent measurement off of it. I'm gonna call that 12. Hey, Fair. It's always hard to say your name. Ferocious. 12mm. Extrude. You, and you. -1, 2. Do you want cylinder? Yes, I want cylinder, but with this. No, I don't want to cut. Join. Okay, it's getting there. Starting to look like the differential. Of course, I'm not doing any of the internal stuff. I'm not going to show that. We definitely don't need to have that on this model. Okay, so now the other one, if I wanted the span, I could extrude it from all the way from one end to the other. I am not going to... What? How do you get that from that? I guess I can put it flat on the surface and then measure down. I can point down. Not the most accurate way to do this, but I didn't pull out the surface plate today. We're mostly reverse engineering here. 20.1. So should I go 20? I think 20 is probably the answer here. So 20, and that's from this plate right here, which is our 0. So if I get rid of the body and I extrude this, and I go -20, and then I bring it back in, join, okay. We're trying to use generative design. In order to use generative design in Fusion, I need to tell it the do's and the don'ts. I'm trying to create the frame of the RC car using generative AI design in order to make kind of like a monobody for this, because I think it would be cool. Also because I want A-arms on the top of these. That's one of the advantages, I guess. Also because it would look cool if it was like a spiderweb kind of car. So I've taken our original model where I only had to do the electronics and then I'd finally be done this project, and I have taken away the stuff that isn't needed in generative design. So I've taken away the carbon fiber plates and all the all that other stuff, and we're going to put the gears and the differentials back in so that I have areas that I can define and plates that I can make. It's going to be basically like the differentials I can hold together either above or below. I can have something bolt in order to hold the bearings in the places that they need to be. So what part is it? It's the body of the RC car, the thing that's going to hold all this garbage together. So we found a model for a differential, and it wasn't quite the right thing, although it does look like it would fit in the WL Toys kit, and it would have metal thingamajigs over here, which might actually be really good for the WL Toys. But they modeled this, and they didn't quite get it the way that we did. They have kind of like, I don't know, they've got this type of tooth over here, whereas when we look at ours closely, we have little triangular teeth. And our little triangular teeth are radial from the middle. And so we took a little bit of time to try to figure this out, and we were able to emboss a pattern around a cylinder after some measurements and some tweaking of the measurements. One of these teeth is not like the others. It has a slight, ever so slight, straight spot right in the middle. Yeah, the body of the RC car. We're trying to make the chassis. See how it's got just a little bit of a flat spot right there, but that's not really going to affect us very much. That won't affect us very much. This is the WL Toys differential. What I need now is a cut down the dog bones. They're called dog bones because the axles themselves look like a dog bone. I'm pretty sure I've got that terminology right, but let's just see. What do we got here? 1 millimeter in. 2 millimeter cut. There's a little screw head at the bottom of that. 5.6 millimeter. Oh, I see how I can adjust it now. I don't need to go all the way in. I don't need to take the diff totally apart. Apparently, I mean, there's grip on the outside there, but you can go in through here and adjust your differential. That would have saved me a lot of time. Was that 6 millimeters on both of them? Yeah, 5.5. I'll give it 6 millimeters on both of them. So I need a couple more circles in the sketch. So this would be 4 millimeter. And then I need a center box. So rectangle, center point. Doesn't matter how long, it just needs to be wider, and that needs to be 2 millimeters tall. There we go. Finish. So now I can take, I can just bore out the whole thing, I guess. Oh, I would need to go symmetrically in both directions. Might as well. Actually, no. I can only go 5 millimeters in from each side. So yeah, let's take that. Let's bring our body back. Let's start from the object over here, and let's go -5. Wrong way. Let's go 6. There we go. The indent? What indent? What are you talking about? That is 1 millimeter, right? Yeah, 1 millimeter. I'm giving it 1 millimeter, so we did -2 on the diameter. What does it use? I don't know what the names of all the RF things are. The FSGT3C is the radio that I'm using. G hertz. Oh, AFHDS, whatever that is. This thing is no longer the WL989 kit because I'm using a lot of different stuff now. I'm using the DOS Micro 8-channel, probably AFHDS receiver. This thing's great. All right, so same thing, other side. Bada bing, bada bingus. And start object U. -6. Okay, and now we get the cut of the bone. What is the cut of the bone? I need to measure that. How about a power drill battery pack mod for the remote? That's an interesting one. Does that exist? Probably does. People are using this stuff, which makes it fairly popular for people to make all these cool mods. Now, this isn't a vital thing, but that's 6. It's also 6. All right. Hold on, I gotta refocus the camera on this so that people can see the stuff. Put this over here. Okay. I've spent a considerable amount of time modeling all the parts that you can buy for this car. Can't believe I had to go this deep. All right, who? What the? Code Rushed? Hey, Code Rushed, I need to know, like, do you have a YouTube channel or anything? Because I can, in the comments of the VODs, the times that you've rated me in the past, I really appreciate. I don't know who to give credit to. I did a little digging and I think I found like a YouTube, but I would like to give you credit in the descriptions for all the videos in my VOD channel. But yeah, hey, thanks for rating. We're working on the RC car, which is in shambles right now. We were going to do a little frame for the electronics that sits over here, but like, I don't know, I'm too crazy and weird to just let it sit at that. So instead, what we're doing is we are modeling the differential at the moment, and we're going to do the spur gears on the end and figure out what the bearings are. And I would like to eventually do generative design. Generative design is when you have multiple different designs created by AI and you choose the best one. I don't know if this is going to be totally possible, but it creates some really weird stuff, and I really like what it creates, and it would be cool to have an RC car that uses this stuff. Here, where's my window? I have so many windows open. Well, you just look up generative design. Now, in order to do this with Fusion generative teapots, generative teapot. That doesn't quite look right. I think it's mostly just AI doing it. But anyway, this is a way where you give it constraints. You tell it, hey, I need this amount of force here, this amount of force there, and here's an attachment point that I need, here's an attachment point here, here's the boundary that you need to stay within, and the AI will go through iterations and figure out what complies with your constraints. And so you get these very organic looking, interesting sort of bone designs. I want that here, but here is a very small design. That's a very small area to work within. See, instead of having ribs that are done by engineers, you can have like organic, weird shapes. All of these things are much larger than what we're designing for, though. Our material is much softer than the aluminum that I believe, or 3D printed, I think those are. Our material's much more soft than that. So Fusion 360 can do this. You need a paid version of Fusion 360 in order to do this, or an educational copy, which is what I have. So if you're a student, you can do this. The only limitation is that if you do it too much, you will grow hair on your palms. I mean, you will actually get rate limited by Fusion. They'll go, what is that naughty person doing? And they'll stop you. So just a little piece of that. Okay, so we are currently making the differential, and then we're going to make it look good. So I'm going to hit extrude, and I'm going to go from an object here, and I'll go -6. That'll make my cut. Look at that. It's already looking like a dog bone. Do the same thing on the other side. Pop. Extrude. So yeah, this is what we've been doing. In the background, I have been uploading YouTube videos, and it's been excruciating to watch my old videos. I don't know why you used to raid me, Code Rushed, but you still do it. I don't know why. People are like, oh, interesting content. No, that's not why. That's not why. We don't need the hole through the middle on this. I'm just going to do some fillets. Let's get the sketch out of the way so we can see what we're doing. Ah, not you. No, give me this back. No. Okay, fillets. And I'm going to select all 4 of these and just round them off. And then over here, some of them don't have rounded base features. I don't know what's going on. Future's looking bright. I had no idea AI was capable of doing stuff like this. AI in engineering has been a thing for a very long time. The super duper unobtainium expensive circuit board suites have used AI for quite some time in order to do circuit board layouts. That was like back when I was in like college, early college, that they started doing that stuff. Because laying out circuit boards is a little bit more simplistic, but if you give constraints, like you can set something to iterate through stuff that's been around for a long time. Yeah, auto router type stuff was AI. Some of us are trying to learn Fusion 360. It's fun to watch others work in it. That's, yeah, I mean, I'm learning too. I'm with you. I understand completely. I've been using Fusion for quite some time, and I'd probably get a terrible grade on my report card. Now, the bearings, wait, does that bearing block the... No, there's like a little bit of space at the base of these, but it doesn't... There's a little bit of space on that one, but is this one a bad measurement? Because they both have about the same amount of room. Actually, the one on the left seems to have less, even though that was the one. Yeah, I think that's a bad measurement, that 12 millimeter one. Yeah, OGAI, not a language model. We're talking about AI that's not a language model. It's not doing autocomplete in order to figure out what it should be telling you, and it doesn't lie. We're talking about like real AI that was intended, using for the purpose, functioning for the purpose that it was intended to be used, and it's got all the right data set in order to do that. It's been around for a long time. From there to here. Well, that's looking a little bit more like 11.5, isn't it? Maybe we'll make that an 11.5. I mean, the measurement that I need to get right is from here to here, which is 14. That's a nice number. The 14 between those two. Let's see where we are with that. From here to here. 14.18. That's actually very close. Should we take 0.18 off of this one? Because it does look uneven. Huh. Maybe that one's not long enough? Let's double check that. .2. Expect from here to here. Yeah, that needs to be a little longer. Okay, so back to this one. 2.18, 2.2. And now this needs to go a little less. Yeah, 14.2, so I'm getting 0.2 out of here. And then negative 12, negative 11.8 is less than that. I mean, it doesn't look like a bearing is going to fit there. What's our end-to-end measurement? I gotta keep clicking on random stuff. If people get banned in chat, it's because I accidentally clicked on something. 31.52, I think is a little cursed. Yeah, 32. So we're missing like an entire millimeter somewhere. This thing is a ball differential. So this thing has ball bearings inside of it, and then a mechanism to put pressure on those ball bearings. And so when one wheel moves faster than the other, this will make up for it and make it so that the car has a much better turning radius than it would otherwise. Apparently it's adjustable from the outside, and I didn't know that. Hold on, I need a flashlight on this. Is that like a hex slot? Doesn't really look like one. No, it looks like that's the threads for the thing that it's tightening, which might be the screw here. I'm gonna test this. All right, come on, focus. Focus! Oops. That seems to be directly connected. Oh yeah, and that's not doing anything. So that tightens against this nut, and then that tightens up the differential and makes it less differentially, which does not... Yeah, that can't be adjusted from the outside, I guess. Unless you shove it like a toothpick in there. I know, it's like some kind of a horrible dentist tool to shove into your face. Okay, measurement differences. We're missing like a millimeter, and I don't know where that millimeter is coming from. Probably from this measurement here. Because like that's fudging the number because I'm measuring diagonally right now. So how can I measure this better? I could go from here. That's dead reckoning that I'm doing right there. That's really not accurate. 11.7. That gets me closer to 12. And yet we're still missing a millimeter. The overall width of the gear itself is 3.16. I'm actually not using that width. I'm not using the overall width. Let's go to the microscope. My datum is basically the back plate of this thing. Can I get a flat... No, not really. I could do this. This little motor tool that I got. Oh no, that's not helping me at all. Never mind. That doesn't help. It's just a plate with a cut in it. All right, let's see. So, get out of my way, everything. Everything move. The important thing is that my bearings are the right distance apart from one another. And it's strange, though. This one looks like it's the more restricted one. That's the tip of the screw there. And then this one seems to have a little bit more room down there. And these are to accommodate the bearings. And it's important that we get the bearings right. What type of grease does he use? I don't know. You can figure that out. You can buy fancy RC grease all day. I actually found that dielectric grease is pretty good in the RC car. It's a racket. There's a lot of rackets in RC stuff. There's like a little spacer on it. There's like that little spacer. I guess that's so it hits the inner race of the bearing. And this one's just designed a little differently. We're not accommodating those designs. We don't need those designs to be right. We just need the distance between the gears to be correct, so that I can tell the housing what to avoid. I guess maybe if we find a bearing, I can try to put them in place and see if we get the right distances. The bearings are going to be standard. Thickness being 3. Diameter of the inner, ow, poked myself really hard. 6. Outer, probably 8. 10. So 1036 is a 1036 bearing. I don't know what order the numbers go in. In American, we put our dates in weird numbers. In weird order, rather. So in order to find that bearing, we can try to see if it's McMaster car, or we can find it on GrabCAD. I'm going to try GrabCAD first. I think it's a little cleaner to pull in from GrabCAD. But you can, like, the full catalog of McMaster car is in Fusion. The only problem is it pulls it in as like a step file, and it's like a really messy step file. Yeah, GrabCAD is very nice to have and use. And most of it is Fusion, isn't it? Let's get rid of some of these. Okay, let's see. This differential was, sorry, this different, where is it? Whatever, the one we found on here was very close, but it wasn't quite the right thing. Molybdenum. I used red grease on mine before. Now, what order do the bearings go in? Because yeah, I could do bearing. That's the dumbest search ever. It's going to come up with 10,000 things. Let's try 10 millimeter bearing. Mm-hmm. 1062 RS. Double sealed. Inner diameter of 6. Outer of 10. 3 millimeter thick. Download. It's a little shiny for my taste. The model will be more matte. So extract that to file, folder file for thing. 1062. There we go. I guess it would be a 10.6 bearing. Where's the 3? I guess 2RS is the series. Okay, so new. Oh no, not new. No. New one of these. Upload. Oh wait, bearings are in a separate folder. Bearing. Are they in a separate folder? Generic parts? Yeah, that's where we're putting bearings. Upload. And then I'm just going to drag and drop the STL file. F3D. So you got F3D, you got step, and then you have STL. And then you have the other one. We'll do the F3D file. 3MF, yeah. There's a lot of different standards. Does Fusion import step file materials? I think it, if you have the F3D file, I think it does. Shorty and I have tried to share designs between us, and we've had a lot of trouble. This is so much shinier than the actual part. It's ridiculous. These designers, these parts designers, this thing, this is what it looks like. You know, it's not exactly shooting laser beams into my eyes. It's not a mirror finish. Let's try to fix this. I have a passion for making things look right, even though not getting the materials wrong, but making it look right. So it's probably stainless steel. So we'll go to metal. We'll go to metal. There we go, metal, and then we go to stainless. Stainless. It actually kind of is brushed linearly, but I think stainless satin is what we need. What is that appearance up here? Whatever, stainless satin. Now, what do we have? We've got different bodies. Sometimes they even model the balls. It's crazy. You like wait for the mouse over in order to see what it is. That's the one. Okay, so that and that. And then the inner piece is, I mean, we could make that stainless satin, but it's more of like a tin. Or is that part of the other part? These are very cheap bearings, so interesting. There's like barely a little gap there, but the rest is still satin stainless. All right, so we'll just make it the same thing to render a very boring looking part, but that's what we're here for. So cool, now we're done. Save that. That's my new part. There's 11 competing standards. We need to fix this. Now there's 12. Yes, that is an XKCD. Okay, cool. There's our boring bearing. Coming from this person who made that file originally has a passion for bearings, and they poured their heart and soul into it. We made it boring. Now that's going to make this an assembly. Usually I don't like to do that, but this stuff is permanently attached, and we want to figure out the measurements. So I want to pull the bearing in here to make sure that we get everything in the right spot. I'll put it at 80 degrees. Just put it off by just a little bit. Okay, so this is kind of beveled, so I need to make sure that I get the outside edge there. And I'm going to, oh, winter storm warning. Oh, we're gonna get snowed in again, and we don't have a ton of food in the house. So I'm probably gonna have to break to go grocery shopping. So we're gonna move this, but we're gonna create a copy. Make sure to check that first. That create a copy should be up higher. And then sometimes when you go between the different modes for moving stuff and arranging stuff, it will uncheck some of the boxes. You need to check back with all the other stuff. Whoever programmed the UI, I think is just like a little bit like anti-engineer. I think they just kind of maybe it's just like a bias, maybe the back of their mind. They don't realize that they're being like this, like a microaggression. But like some of the UI choices in Fusion are just maddening. Oh yeah, I want to move this on the regular coordinate system. Oh, you can't move multiple objects, so we'll just unselect everything. That's wasted so much time in the past. It's just like, oh yeah, I'm gonna unselect just about everything that you selected. Have fun, asshole. But yeah, these are the quirks of CAD. What is this view? These are the quirks of CAD. Every CAD has their quirks, every single one. So we're going to do a point-to-point move. We've got the components selected. We need to make sure that it's actually selecting components, not bodies, because if I select a body on that thing, I might separate my part into a billion pieces. And then I am going to choose any of the outer circles. So any of this, any of this. So my first point, I'm going to make this, just for fun. And then I'm going to select that ridge right there. Now, if I change the size of stuff, this isn't going to follow. Oh yeah, we wanted to create a copy. Luckily, we can click that afterwards. Sometimes you use the move tools, and then you can't create a copy. It just drops it. It just doesn't care. That's what I'm talking about. Somebody hates engineers. So there's something, see, there's something wrong here. That covers in there. That's not the way that the differential looks like. What did we get wrong? So we're going to move copy this one. I like selecting the component and hitting move copy. Selecting it for the tree is sort of the galaxy brain way to do it, because then it has no ability to argue with you about what exactly you're trying to select. So I'm going from here. I'm going to make sure that's the outer one. I think it's the outer one. Let's reselect it just to be sure. On this side of the bearing, there's a bevel. Or is there? I don't know. Let's choose that one. So origin point, go from the surface to the very first line that I reach. And now I can go over here. I can place it right here. Because I'm pretty sure that PSpice is actually a prank against engineers. I'm pretty certain of that. What I find bonkers is that Autodesk clearly has competent engineers. Yeah, it's like, I used Inventor previously. I didn't get too far into it, so I don't know how competent it is. What kind of internship project was Fusion, though? How is it that it still doesn't render curves properly if zoomed in? Yeah, there's a lot of stuff in Fusion. They're like, oh, it's the free version, so we don't work on it. But it's like, dude, the free version is the lifeblood of your company. If you want to get sales outside of engineers, which is pretty big deal for such a capable program, like, I don't know. They're holding back the advancement of mankind. I'm gonna get mad at them like my friend is mad at Intel for holding back technology until they can compete with it. All right, so let's get a measurement here, and we'll figure out exactly how wrong we are. How wrong are we? I'm not gonna do the little lips, the little 1/4 millimeter. I think they're like 1/2 millimeter. But if we can just get the distance between these two correct, I'll be happy. So from the outer edges of the bearings, I got 20 millimeters. That is unequivocal. Ain't no arguing with that. 20 millimeters between these, and after all of our hard work, we were able to get exactly... You're right, it's like not rendering when you zoom in. There's a lot of settings, there's a lot of visual settings. I think you can correct that in the visual settings. Oh, we get exactly 20 millimeters. We get exactly... Wait, then why was my measurement from the ends of the dog bones wrong? Maybe my measurement for the dog bones was incorrect. Because yeah, this one is like buried. So what about the distance from the end of the bearing to the end of the dog bone? 5.2. Oh wait, that's on the wrong side. We are on this side. It actually does cover over it a little bit. 5.9. So we've got a bad measurement for this extrusion, which is 20 millimeters from the center, so I'm going to redo that measurement. It kind of wants to be like 20 and a half, maybe. Kind of a tough one there. I'm getting 20.8, 20.9. So if I make this 21, that looks like it meets up better. And we'll check the width here from here to here. 32.52, measure from the end to end. 32.14. Where's the weird number coming in? 32.5 is a little bit much. Isn't the only difference between free and paid what it lets you do after you enter a valid license? Yes, with Fusion 360, there are limitations that are placed on certain functions. The credit thing is understandable, but not to the degree that they do. Sorry, I'm reading comprehension is above me. I mean, come on, rendering that I have to pay for. Next time we have to pay for downloading our own models. Well, yeah, I know. It's like rendering is like a big part of the software. I use the software without rendering anything because I think it looks good enough as it is. But yeah, and then the prices are like $20 for everything, but it's more of that they, what am I trying to say here? They're catering to people with money, not us hobbyists that are broke as hell and just trying to learn a competent suite and maybe gain a skill that could be marketable. They don't care about that. They want the people who use the student copy throughout their college education, me, although I only used it for, actually, when I was in college, Eagle was a different program from Fusion 360. Well, Fusion 360, Eagle was a different program, and Autodesk was a command line. So, you know, 6.32. This one looks off by a little bit. It's a little bit further out from the bearing. We're starting to see the evidence of this being like an actual design, right? We're starting to see that, like, oh, this is supposed to line up here, this is supposed to line up here. The inaccuracy of my calipers is starting to kind of show through. These should be equidistant to the bearing, I believe. And I got 6 on that one. 6 seems to line up on this one too. So it really should be 6 millimeters away from that line. And then the distance between the two should be 20, which I think it already is. This will just make us have less headaches at the end when I get this right. Okay, so there's 20. So if everything is centered on that 20, then the 6 millimeter distance from here, so we'll take them back so that they're exactly, so that this is even with this, which means measuring from here to here, and that should be 6, but it's 6.2. So let's look at where we render that, and let's remove 0.2 from here. Oh God, really? 20.8. No, 20, yeah, 0.8. What a dumb number. All right, let's go to the other one and measure from here to here. 6.32. This. And then the beautiful thing is that instead of figuring out what 5.2 minus 3.2 is, because I'm broadcasting right now and I'm kind of being a silly guy just a little bit. I hope just a little bit. Math is so hard. It's so difficult. Don't make me do math. What I can do is I can actually, well, first of all, get out of my face. What I can do is I can just put an equation in there. (11.52) minus 0.32. And you could put more complicated equations in there if you're smarter than me, but simple addition and subtraction is beyond my recognition at this point. And so from the 20 millimeter distance from bearing to bearing, we get the overall distance from dog bone to dog bone, 32. All right, close enough. I'm willing to say close enough on that one. There's, I mean, everything has tolerances, and we're just trying to get to the bottom of that. This, if I squeeze the calipers in just a little bit, there's that Reddit post where somebody was trying to tune their 3D printer, and they're like, look, I got it perfect. And their thumb on the wheel of the caliper was clearly stressed out. This is a little bit, we're a little bit more than 32 on this. I wouldn't quite accept 32. But as an original number on the design, you know, before your molds wear and stuff like that, I guess it's kind of acceptable. Used to do physics in my head, and now simple math can sometimes be challenging. Yeah, it's, I don't know if it's my advanced age at this point, but certainly math has been beyond the scope of my ability to because I'm, you know, I'm coming up with the ideas and the design and the direction that stream is going, and I'm trying to be entertaining. I'm trying not to get stalled up, and I'm trying not to sit here just like working on this design. So CAD Soft Eagle was really a dumpster fire. It kind of was, yeah. 5.0 put 9 up to 9. I had 7, which was the last non-subscription version. Apple branded wheeled dumpster with an Olympic flame in it. The wonderful part is that you don't have to go too deep into Fusion. When you do go too deep into Fusion, like trying to use it for its express purpose of designing a circuit board and then designing solids around a circuit board, if you don't know where the bumpers are, you're going to be hitting the bumpers constantly, and things will go absolutely sideways on you. All right, software, but I don't do math. There's people who wrote stuff and already figured it out for me. Okay, so we're looking for plastic, and we're doing opaque plastic, even though I probably could just choose like nylon, but that's 3D printer nylon, so we'll just do a matte black plastic. The only thing I don't like about the renderings in Fusion is that when you make black plastic, you can't see any of the contours or details and stuff. They need to lighten it up a little bit. And I think somewhere in my appearances there is a lightened up black plastic that I can see a little better. It's just because I use the white background mainly because I have a face light, like a softbox face light sitting right over there, and that's why you can see me in nice detail, and I don't look too shiny today, but yeah, it's because of the big face light giving a nice soft light, so I look beautiful. But having that light in my face, that's the wrong monitor. Having that light in my face means I can't see what's going on here. I can highlight over things and they sort of manically blink. But anyway, that's our differential. We got a differential now. How in the hell am I going to figure out where to place this thing? So we'll save that as WL Diff version 1. Shiny streamers are sometimes I have been shiny on camera and I'm like, how's my liver doing? Like so we no longer need this one. And there's our model. We got to get that centered in here. And it's actually centered on these points at a particular height. How in the world? Well, the differential housing still exists in the files. So let's find the diff housing. Oh, you know what? I could... No, how would that work? Model the pinion, pull it in. Nah. Doctor, I'm glowy. I could be a CIA agent. All right, let's find the housings. Here we go. Those housings are actually in 2 parts, but maybe I can use them to co-locate stuff. I wonder if I could 3D print a part that goes, I don't know, convert it into having 2 A-arms by having a part that, like, there's no material there though. It would have to go up and over. I have to go up and over to get that right. Push comes to shove, maybe that's my option here, but let's see here. Yeah. Use dark mode. It's annoying when YouTube vids are all in light mode when I'm trying to learn more. Sorry, you gotta have to go get sunglasses. or open the window or go touch grass or something. I don't know. So I think I can locate it on this. So let me bring in a diff. It's, you know, engineer, jack of all trades, right? You're expected to know all the software if you would like to have work. So where did the differential go? WL diff? Oh, these are generic parts, right? WL. So you need to be able to use all these CAD softwares. They all have different workflows. And so when you start off, it's going to feel like, you know, walking in molasses. Why is it called generative design? The AI will go through and bit by bit generate different designs based on the parameters that you've laid out for it. So you tell it, and the thing is, we're not going to get to generative today. We need to set up all of the different constraints that generative is. Never use dip trace. Got it. We're gonna set up all of the rules that it has to follow in order to make the design. Boom, headshot. Beautiful. That fits beautifully. Hey, look at that. We got a differential. I don't know which one's placed in which direction, but I don't think they're symmetrical. So I'm gonna have to go in and make a new solid that covers all that stuff and gives me the things that I need in order to tell it what to do. I started out by watching a tutorial on how to do this. Okay, which housing is this? It's this one. Yeah, we got a lot of work to do before we can tell it what to do. How are those even? That's weird. These things are down, I guess, when they're flat. Yeah, weird. Okay, anyway, let's take this again. Where is that? It's all the way down here at the bottom. And let's move copy, because we're going to copy, and I'm going to use point to point, but first I got to flip it around. So create copy, and let's flip it around. And then I'll just use these to kind of get it out of the way so I can actually do a point to point. I'm going to choose the right side. So we're going here. We need this circle. Boom. All right. That's looking pretty good. Hey, I got unlocked a new level of detail of my model. Cool. I got more useless crap modeled in this thing, which actually means that if I abandon generative design, I could try to make my own bell housing, which is probably the way that this is going to go. I'm probably going to make my own bell housing eventually, and that way I will have the ability to have 2 of the A-arms, and then I'll actually have some suspension travel. This is the part where animation of the model starts. No, we looked at the animation at the very end of last stream, and it looks like an extremely powerful tool. It looks like another like full video editing suite that I need to learn. It would be cool if Fusion Autodesk had their own video editing suite, but yeah. But if you need something like ODB plus Old Dirty Bastard plus, KiCad might never implement it due to licensing. That's unfortunate. Yeah, this is cool. If I need my own housings here, I can make a much more simplistic housing that'll hold things a little stronger now that I've got the differential modeled in here, which is probably the direction that I'm going to want to go. But I would like to use generative design because I really want to have some kind of a cool engineering looking spider design on this thing. Also because it would probably get clicks. You YouTubers are not alone. We see you over here on Twitch. The Twitch viewers can see you on the screen. You can hop over to Twitch and you'll be able to hear intro music is the only thing that Twitch has over YouTube, aside from good emotes. But pimp my RCT pot. I'm actually working towards running a generative design thing on this. We'll eventually get there. It'll probably take another stream or so because we have many more parts to design. Why is that colliding? Maybe I just need to move that back. We need to model the pinions. The pinions that'll take, yeah, it looks like this whole thing just needs to move back. The switch is kind of bugging me. I don't need this switch. Well, whatever. Let's just leave it right now. Just blew up a potentiometer in my steering, messed up the pinout on the headphone cable I was using to run it. Do you have more, or did you use like the nicest rare one that you have for your steering? Because that's what I would do. I would be like, this isn't exactly the right thing, but I'm just going to use the super special one. Okay, you have more. Because then I'd blow it up and I wouldn't know what to do after that. Be like, well, now I got to find something that was made in 1975. Okay, we've got another gear to model. We have a pinion gear to model because that carries a bearing with it as well. So this is easy because it's just a spur gear. Spur gear is just one of these normal... Here, where does this thing go? One of these normal Jim Jams. The thing that's not normal about this Jim Jam is that it's got this flat portion, and it's actually, I think it's like bonded to this. I can't get it out. I can't get this out of here. Nope, can't do it. Anyway, it's got a bearing, and it's got a little seat for the bearing, and then it has the spur gear on the end. So what we're going to end up doing is modeling the spur gear, and then everything following is going to be Kirsten through the primary axis. I don't know what ODB++ even is. This is like, I can't get the bearing out of here because there's actually a little bit of a lip there. How am I going to measure this bearing? This is like married to the WL Toys kit. Weird. Well, the other side has one too. And I guess I could get it out of the other side. Yeah, that's what I was saying. It's Old Dirty Bastard has been resurrected twice. That's why we get ++ from. How many teats do we have on this gear? Well, I'm going to need a mark, and I think I need a marker for a mark. Since this is light plastic, I'm reaching for a pen. There's a difference between between topological, okay, hold on. Topological optimization and generative design. Is it that they're both just like a mouthful to fucking say and they're made up by people trying to market stuff? Because that's what they are. Popolobologus. I don't know what I'm saying. 1, 2, 3, 4, 5, 6, 7, 8, 9, no, 8. Well, 8 troughs and 9 spurs, right? So 1, 2, 3, 4, 5, 6, 7. No, it's 8. How's it 8 and 8? I guess 1, 1, 1, 2, 2, 3, 3. Yeah, that's how it works. So 8 thingamabobs. 5 millimeters. We are going to generate, using the utilities, a spur gear in metries, the module in millimeters. Number of teeth, 8. Gear height. A lot of these are even millimeter numbers. Good on WL Toys. That's 3 millimeters. Pressure angle, no idea. The module of a gear. Let's look at a module calculator and see if we can figure this out. Gears are tricky. They've got a lot of numbers associated with them. Spur gear module calculator. Gear dimensions calculator. This is the same one that we had. I think this one is meant for cutting gears, isn't it? Yeah, here they want the module. We want the module. We want it to calculate it for What is this? Number of teats. 8. Oh, they're saying module. I want the module. I don't have the module. Circular path, circular thickness, face width, bottom land, top land. Oh boy. Yeah, gears are a lot of math. Center distance, no. Spur gear module. Unit size that indicates how large or small a particular gear is. What does that even mean? Unit of gear tooth size defined by ISO. Gears will only mesh with each other if they have teeth in the same module. Okay. Oh God, what does it mean? Spur and helical. Table 1. I remember there being like a calculator that I could use in order to get the module. I don't know where that came from. Measure the pitch circle. I really would. Module is little d over capital N. Ratio of the pitch diameter, d, to the number of teeth. The pitch diameter, so which, it's a really great picture that you can definitely read all the captions on. What is this picture? Open image, a new tab. Here, let's take a look. Ugh, my eyes hurt. Why do my eyes hurt? Circular width. Is it a measure from center to center? I don't remember how I got this the last time I did gears, because I did the center gears for the whatchamacallit, for the actual model. I did these two, right? And so those have the appropriate module and everything on them. But the end piece of this drive shaft, I have no idea. I don't have any clue. Pitch diameter is basically impossible to really measure. Fuck. Shit! What do I do? All right. So, wait, why are we in the appearance menu? What was that? Okay. Gear generator, spur gear, module, sure, 0.3, why not? 17, we'll go 8, and then the gear height is 3. Zoom way in on this. Way too big. Oops, what is this view? Actually, that actually looks kind of accurate, to be honest. Where's my microscope view? It is somewhere on here. Or no, wait, I'm trying to do this and then add the microscope in so you can see what I'm talking about. There's been some traction with YouTube with the videos that I've been uploading, and I am shocked. I am shocked. I'm glad you guys are finding my videos all right. It's that whole daily upload grind. Luckily, I have 3 years of videos, well, 2 years now of videos still to upload. 273 or something like that left to go. It's an insane amount of e-waste to be dumping on YouTube, but I guess that's what they want, so that one day in the far-flung future they can actually create an oh bother that's purely AI, and I can tell you things like, don't plug that into the wall and kill yourself. It's okay. What is happening? What is, hello, OBS? What? Okay. There, and then where's the second one? There it is. Yeah, so all right, I think I'm willing to just leave that one alone. I think that's okay. I just went with like a, where are the videos oh bother? Yeah. That's what people ask Rabaz constantly. Where the, oh, I see, that shut me down. Okay, there we go. You know where the pitch diameters are. You need to measure it over pins. Yeah, I don't think I can do that. Okay, wait. Standard pressure angles are 14.5 or 20. I think we're in a 14.5. It seems pretty right. Sorry, chat didn't scroll because of the automated social stream decided to not scroll because of this. It's like when there's a big enough comment, social stream just goes, I'm gonna stay in the same spot. All right, so the diameter of the shaft, I believe, is the hole in the middle of this. Actually, it's a much smaller hole. What the hell? It doesn't really matter all that much. That's probably a 1 millimeter. Okay, let's see. So we need to figure out what that is. That's 0.5 millimeter, and then probably another 0.5 millimeter. So there's a disc on the back of this thing. So I guess we probably should go vertical. I always go down into the ground. We can do a sketch on this face so that if I need to change that distance, it'll just change where our sketch starts. But I'm pretty sure the numbers are pretty even. So we'll do circle from the middle. That's 1 millimeter. That is way too big. Well, that 1 millimeter circle, okay, so there's like a 0.5 millimeter ring around the teeth. There's a ring around the entire thing. And then we've got the back end where there's another piece that holds the bearing. See, they put this little 0.5 millimeter inner ring so that it contacts the inner race of the bearing, so the bearing spins properly. So this is not what we need. And then we're going to do from the center just to the edge there, and then we're going to take that and we're going to offset it, and I'm going to do negative 0.5. Really? Negative 0.1. Okay, that looks a little bit more accurate. And then we also have a circle all the way out to the outer edge of this thing. So I'll go to just the center of one of the teeth there. Why is that not locked down? Oh, it's weird. Well, maybe I should measure it. One and a half. What? 3. You think they're using mod 0.5? I don't think I can get back into the spur gear settings in order to correct that. It looks so very close to what we have. Why would they be using mod? You just know this from experience. See, Short Lurker is on California time, so he comes into stream like way late. So all of this like scratching my head that I do ahead of time, he already has the answers for. It's like magic. Where's the microscope? Hold on. Wait, that's the oscilloscope. That's not a microscope at all. Oh wait, no, we're looking at the microscope. What I'm trying to do is this, and then I'm trying to pull in the microscope. I think that's pretty accurate. What was our modulo set to? I don't remember. Yeah. Okay, anyway. So I've got common size so close to being interchangeable to 48. Did we run 48? I forget what we ran. Why is this still not attached to anything? The blue lines mean that it's not locked down into dimensions, and I don't know why those are, like, these should not be blue. Because we're centered here, and our distance is 3. So that should be a black line. That should be locked in. Very strange. Mod 0.5 or 0.6 is the metric equivalent. Man, how do they figure this stuff out? For my RC car days, 48 pitch and 64 pitch gears are the standard. So Traxxas and okay, all of them use. Huh. What were the default? All right, hold on. Finish sketch. Let me just look at this. Spur gear. Wait, hold on. I mean, our pressure angle is 14.5 and our mod is 0.3, and it looks accurate enough. It actually looks like pretty on the spot. So I don't know. 0.5, 0.6. Yeah, it doesn't seem like this quite agrees. Anyway, back to our sketch. Are we going to be able to put a hole in this component, or is this fixed? We'll have to see. I think maybe our component turns into a thing when I extrude next to it. We'll see. True. Yeah, you just run it and see if it starts shaking your bones. So what is that? That hole in the tip of this thing is weird. I think it's like really, really tiny. Need to put this on a button so I can flip to it constantly. Let's see, I got the weird ring around the outside, and then I've got this tiny little hole in the middle. What is a tiny little hole? Not necessary, but it'll be nice to have that detail in there. Cosmetic, that would be. I need 0.5, right? Seems about right. Oh, good, I can cut it. All right, shaft diameter is, well, I have a part for the shaft that I could pull into this. We should make the housing of the spur though first. So we've got 0.5 millimeter and 0.5 millimeter on those two flats. So let's try that. Hey, print technology, has it been a while or has it not? I can't recall. my brain doesn't work. Extrude, E. Oh, let's go back to solid. E. And then unfortunately I have a lot of stuff to click. And then 0.5. Does that look too far, or does it not look too far enough? Looks like kind of a tall gear, actually. As long as you use the same mod for all the meshing gears, it'll be fine. I don't know what I used. We're not printing these. These are purely cosmetic visual aids that we will then have to make surrounds for, so that the generative design function doesn't infiltrate that area. We can basically cut them out of a big solid block, and we can tell Fusion, here's all the forces, here's all the stuff that we need you to preserve, here's your canvas. Make something that meets all of my criteria, stay within this area, and create this thing that will handle all of these different forces. I don't know if that's going to be great, because there's not a lot of extra room in this model, and I don't know if generative design is going to have a lot of great ideas of what it should do, unless I expand its upper area here a little bit and have the battery come in from below or something like that, which is a consideration, but there may be some impossible things and we might be biting off a little bit more than we can chew. I wanted to play with generative design though, because I have access to it, and I think it would be fun. So we're going to run into the problems head first and then go, what the hell hit us in the head? I need measurements. I need photos, and they need to be of Spider-Man. Where's the microscope view? There it is. I need J.K. Simmons. No worries, no worries. I realize that there's a language barrier in a lot of cases. You guys are awesome for catering to my Pennsylvania American accent, and the fact that I will call things Johns, and you'll be like, who is John? These Johns over here? Need to meet up with these Johns over here. I told you it was 0.5. This is another 0.5 right here. What is that radius? I will speak quickly and passionately about things, and I will leave people with a language barrier in the dust. You can just feel free to, ask me questions. I'm going to call that 4. I'm going to call that, wait. Wasn't the outer diameter of this whole thing 3? This thing is 5 millimeters in diameter. Wait a minute. What the? Put a bad number in here. Hold on a second. Wait a minute. Wait. Whoa. Hold on just a minute. Hold on, wait a sec. Hold on. 3 millimeter. Okay, so we screwed up. Goodbye, all of these lines that I cared about at one point. Anyway, hey, Oh Bother here. Welcome to my stream. Thanks for joining me. Today we're going to make a spur gear using a utility that I just got called GF Gear Generator. Never used it before. Seems pretty cool. So we're going to start with metric, standard, use fast compute, why not? Now the module, it's actually funny that you should say the module for RC Car Days, 48 pitch and 64 pitch gears are totally standard. And I came to those numbers through my own research. That was my own research that I definitely didn't just totally fucking steal from a chat member. Did I have this over top of me the whole time? Hold on, let me turn the microscope off. Okay, so it's 5 millimeters, not 3. What do you guys think I should put for the module? Mod 0.5? Because right now we've got 0.3. 0.5 will probably look okay. I desperately want 8. What happened to the window? I hit a button and I just desperately want H-Bomber guy to come after me, you know? 0.5. And then metric, yes. 0.5, yes. Number of teeth, still 8. Gear height. Yeah, I did 0.53, but I think I hit control or something and the window went away. That's what I was asking about. What about pressure angle? Because mod 0.5, 0.6. So we're going to 0.5. Do we know like common pressure angles? There were 2 that people were talking about before, and I just didn't have the heart to go back and redo it. But now we have a chance. We finally have a chance. I'll see if you guys said anything. Well, we can run this and just see how it looks. God, I still smell like garlic. I made stew yesterday, and while people say just touch stainless steel, it doesn't do a damn thing for me. I can touch stainless steel as often as I touch grass, and it doesn't do a damn thing for the garlic smell under my fingernails. Not that I mind. 14 and a half? Okay. Boom. Let's take a look at that. Boop. It looks blurry. I blame Chester. You mechanical engineers have a much better grasp on some of this stuff than I do. All of this stuff, I should say. That still looks pretty accurate. It looks like a gear. Hard for me to really like, I don't know. All it needs to do is look like a gear, but still, that was pretty good. All right, so same thing as before, same as the first verse. Get that on there. Our sketch is now on that face. Now we do a, I think still a 0.5 actually. 0.5, and then I've got one that comes out to this, and then I've got an inset on that, so I'm going to use the radius thing and do negative 0.2. It's a little big, but that'll be able to make the front face of the gear from the back face of the gear. And then I need the main shaft, which is 3, and I need my little 0.5 offset. Actually, I think that's 3.5. Hold on, I gotta get a good measurement of that. Wait, that one is 3? Hold on, which one is 3? Oh, wow, big comment. Didn't let me, hold on, I gotta scroll down. You guys have been talking this whole time and I didn't see you. Generative design will be just like all of my clients. Why can't I drill a hole through this battery? Yeah. I need to run a wire through this battery, through this gas tank. Idea? I kind of do. Listen, you guys should know, like, at first, some of the friends that I have in real life I met, and they thought I was a complete idiot because I said stuff like irregardless, unironically, but also like I was saying it because it was the wrong word. It's not an actual word. So I got to be careful about doing that too much because I don't think people know as dry as I can actually be. So people think like, did he just like say what I thought he did? And I was doing it to just be funny in my mind. Teeth with 14.5 degrees pressure angles are slightly weaker There's all this nuance that we went over some of it back when I did the gears originally, but like, I don't remember a lot of it. Something curriculum, blah, 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 blah. Okay. ODB++. Oh, okay, yeah, I don't know anything about that. I don't know nothing about that. So there's this little bump at the bottom of the gear that is supposed to be for contacting the inner race of the gear. I'm measuring 3. Outer diameter of this is 5. So I guess that makes sense. So we need a 3mm circle on this. Needs to be 3. Why is 3 larger than the entirety of that? No, that's okay. That's still okay, yeah. Because our other one is out at 5. Yeah, 5. I'll put that in manually so it doesn't change of anything. Okay, so there's all of the geometry that we need. So what we have is we have this, oh God, I gotta click all this stuff. It's probably a better way to do this. There's probably like I can hold down Control so it'll select like the whole of what's inside. There's probably a key that I should press. I'm annoyed that my corgi doesn't want to hang out, even though it's like Arctic temperatures outside. She still wants to sit by the front door. This goes 0.5 into the air. Like we just don't care. And then we unview. I guess we're all on component here. And I'm going to extrude. What am I extruding here? I am extruding the 3mm bumpy. So this thing, oh God. All of these internal structures that it doesn't let me click. I can't even see them. It's probably something that I can do. I've had some really cursed structures in Fusion where I've had to click for like 10 minutes in order to get all of the extrusion stuff. At a certain point, you just want to make a new sketch, but I'm too lazy to do that here. From object, and then I want to go 0.5. That's what contacts the bearing. It's way less than 0.5. That is way too huge. I'm going to double check my work here. Actually, that's 4, first of all. So I'm going to go back to my sketch, and it's going to rewind time for me. And then I'm going to go to here, and I'm going to go 4mm. And let me do an overall height of the spur gear all the way to that. I can't get in there. The bearing doesn't let me get in there. I can use this thing actually as a flat plate. Altium. Altium is one of those ones that has had historically the what you call it, AI design for trace layouts. That's one of the big boy programs. I would have loved to use Altium. We had AutoCAD, and we didn't really have any circuit board design, at least in the curriculum that I was in, motors and controls. I wonder what they have now. Hopefully Fusion. 0.77, what kind of a number is that? 0. So I'm fixing on 4mm here. Like 3.9 is the best that I can report. If I call that 4, am I being genuine? Am I really telling the truth in this crazy world? I lost its perch. I just didn't want to do right by the design. I don't want no trouble, sir. 3.5 is probably the best I could do. Is the code for Paint public? I have a referral that you can use for MS Paint. It's BotherCAD, but you spell the O. The letter O is actually the number 0. And Microsoft will let you have a copy. All right, we're calling that 4mm. I don't want to see it anymore. Here to here. 6. Hold on a minute. Something is wrong. Why is the gear so tall? What did I type in for the height of the gear? the height of the gear, the overall thing I've got, maybe we need to extrude these downwards. Yeah, because we're 4 millimeters there, and then this is 3 millimeter tall. I said 5, and that made the outer radius 5. Should I cheat and just extrude this up 2 millimeters? And now we have our gear, basically. I don't know, I put a wrong number in there. I don't want to go back to that step because it uses a tool, and I don't think I'll be able to redo the, yeah, I won't be able to do that. The old, I don't know what remote masters means. I don't know what that means. The old CAD software that I would use for PCB design was Express PCB. And then there was PCB 123 after that. But 123 had some features in it that were like luxurious compared to Express. Express was essentially the MS Paint for PCB design. You could lay down the vias and all that stuff, and you could order it through them. But you were on your own for every facet of it. You had a line tool. And so if two lines cross over one another, there were no design checks in order to put you in your place. So this would be spur. Let's do D shaft, spur, sprue. I am sprue. Okay, so let's do the front features of this thing while we're here. And the sketch is buried now. I probably should have put the sketch on the bottom surface. That way I would have been able to get to it. Oh well, live and learn, live and learn. So I'm extruding this, and I'm taking it from, no, not to object. Object here, and I'm gonna go 0.1. Nope, we're not cutting, we're joining. You dumb program. Oh, negative 0.1. Because it's barely a feature on the outside of the gear ring. Eagle did not have live DRC for some time, not to mention obstacle detection. Yeah, those features. And then the cool thing that Eagle does now is it actually will move stuff based on the design rules when things collide. When worlds collide! When your stuff starts to collide, it'll, like if you move a via somewhere, it'll push the traces away for you, which could work really well if you had a great idea for what you were actually going to be designing. I never do. All right, and then the rest of this is an extrusion of 3. And that's going to go for how long? I'm going to measure it from there. That's pretty good. 10. Okay. So finding the platins where these folks are getting their measurements from, the piece that comes out of here goes exactly 10 millimeters from here. It's nice to be able to get it right, and all of your numbers are logical. It's also nice when somebody's using Fusion to design their parts. You're like, wait, I know this. This one is 2.35. Oh, that's the inner ring. Which one is 3? 2.75. That's not 3 millimeter. I don't have a 3 millimeter ring. All right, let us make one. On the center, we're going 3. Sometimes when you mess around, Fusion mainly works by planning out. Nice channel, bro. Thanks, bro. Appreciate that. Yeah. No, thank you. Actually, seriously, thank you. What am I saying? Oh yeah. So Fusion, the way Fusion works is you are putting what is, oh, is that the number of viewers? We've got like 1 on YouTube too. You can count that. Oh, print technology is rated with a party of 1. I shouldn't have said anything. Oh, it's your control. What? You've got like water on your keyboard. It's just typing random stuff. The way Fusion works. Sorry, I've been meaning to get through this sentence for quite some time, and we've got it on the schedule. I'll eventually get to it. I mean, that sentence was important to me 2 minutes ago, and then 5 minutes ago when I tried to actually start it and got distracted by literally anything. The way Fusion 360 works, and if you've noticed the way that I've been doing this stuff, is you start with a sketch. and your sketch is mainly an orthographic view, straight on view, and you think about the solids that you need to create. In additive and subtractive design, sometimes it helps to get into the mindset of exactly how your part's going together. What they taught me in college, because 3D printers were basically bird's nest generators at that point, they didn't work very well. What they taught in college was basically starting with a primary extrusion that's going to represent your base metal, and then cutting stuff out of it bit by bit in order to make your final design. That's how they taught it to us now. Well, we have additive manufacturing now basically in the home, and I've realized that it's a lot more useful than I've given it credit for in the past. I put a lot of work into a good 3D printer, and now the way that I think about basically every part that I build is to start on a plate, and from that plate you're adding upwards and you're trying to minimize the amount of overhangs. It's all just the mindset of the type of manufacturing that you're doing. Now, right now, I am creating a part that is an analog for another part. Some engineers just put boxes down and they're okay with that. We're streaming on Twitch. I got to make it look cool and visual, and you know, all the good stuff in there. And maybe you guys can learn little tricks here and there and how to reverse engineer a part. It also helps to think about how the part's being made, like it's coming out of a mold somewhere, and there's got to be a seam in that mold. Maybe they started designing it at the seam of that mold. I feel like I found it on this one because when I measure everything from this sketch plane, I'm getting round and even numbers. Mostly. My calipers aren't as good as they probably could be, and also manufacturing tolerances. So I hope that gives you just a little bit of insight. I almost clicked the stop streaming button. That was the intrusive thought in my head. I was looking over at the button in order to get myself out of the sketch generator, and I was looking at OBD, and I saw stop streaming, and I was about to click the... What is wrong with me? Okay, I almost did it just then too. Finish sketch. Don't look over there. The intrusive thoughts are starting to win. Why did that happen? So the 3mm, I think it's this one, right? It's the one on the outside. Oh, there goes Willow going woo woo woo. If you guys want to see Willow, oh god, I gotta click every single one of these. If you guys want to see Willow, you guys gotta join my Discord, because apparently she doesn't give a, you know, rat's ass about what I'm doing down here. She just fucking does not care. She used to come down here and sleep when she was a puppy, but Willow is my dog. She is a almost two-year-old corgi. She's the cutest ever. Let's bring the component back. We can start, well, we're starting from right here, and we are going a distance of 10mm. Bada bing. That's gonna wanna cut. We wanna join. Bonk. Fake clickbait. I got my degree in mechanical engineering, and I was given exactly 6 hours of instructions on SolidWorks with 0 time spent on how to critically think about making a manufacturable part. I thought that would have been like a major one of the lessons. Mechanical engineers mostly learned how to drink, and I constantly hung out with them. They were way cooler than the EEs. The EEs were very hard to stomach. All of my classes were like the worst thing ever until I met the other controls and robotics students, and those guys were way cooler. I actually got to get a core group. That was a big problem with college, was I wasn't linking up with the people who I could study with, and I needed to do that. That propelled my abilities like tenfold. Teachers didn't know how to make shit. I had a professor complain to me that EEs were getting out of college and they didn't even know how to solder, which I guess that's the world we live in now. You send stuff off to get built. I design it. This should meet all the parameters. I'm going to send this off to the shop and they'll put it together and everything. But it's like, I don't know, if you're going to make this your whole career, like maybe you want to learn how to melt some metal together because it's cool. And that's kind of the I don't know, I like to cover that stuff. Maybe at some point, you know, we'll do like the basic soldering stuff if I can get together enough topics, and maybe if you guys are feeling charitable, you can make shorts out of that, and then I'll salute them. I don't know. We can do something with what do you call it? YouTube shorts. We can get those out there. A lot of the YouTube content creation is going to come from what do you call it? The chapters that I'm putting into the videos now that are releasing on the main part of this channel. As an EE that got formal automatics, that's an interesting one. Automatics, robotics, I feel both attacked and great. My entire career is now predicated on the fact that I torrented SolidWorks 15. I did this with Photoshop, Actually, most of us did this with Photoshop. I don't know why Adobe can't get their heads out of their own asses, but the whole reason that they were able to like basically take over academia was that everybody had illegally downloaded their frickin' program. 2.60 to the flat. I'm gonna make that 2.6. You took creatine every day? I don't know what Creo is. Okay, this is weird. 2.6 minus 2.6 from the bottom. That makes it, that's not point 0.1 for the top? Hold on, I'm measuring 2.6. The overall diameter is 2.5. 2.5. So I'm going to go up 2.4 on this one. No, that doesn't make any sense. No. 2.1. Why was I put on this earth for torture? What's our OD? Hold on. That's the overall OD. I'm doing that wrong. So 2.6 up to the top of the 3mm one, which means it's going to be 1.4. I think 1.4. No, because that would be. Is that right? I'm gonna pull out the calculator. I have no shame. I have no shame. We have a 3mm. I can't read your comments anymore. 3mm diameter because I'm doing math, and I'm measuring 2.6 of it, but it's only from one side, and it should be 2.5. No, wait, I'm measuring the whole thing. 2.6, I got 0.4 from the top, which means it would be 1.5 minus 0.4. So we're going 1.1 up. Okay, listen, streaming, when the lights come on, the IQ goes to like negative values. So we are going 0.4, no. Why did I not do the actual equation? 0.4, oops, 1.5, 1.1. Okay, sorry, I had to redo that because I forgot. This is why I would do terrible on tests. 1.1 out of the 3, which is this one. So I guess I'm just gonna have to draw 2 lines. Actually, I could do a box, but that's okay. So when you start doing cursed stuff like this, Fusion can get a little confused. Remember that you're supposed to be drawing outlines, and each outline gets an internal ID in the program. And the internal ID in the program can get really messed up when you start moving stuff around, and that starts creating and deleting enclosed spaces. And sometimes Fusion will do its best to assume what enclosed spaces you want it to use. So inevitably it gets them pretty wrong. It does its best, but when you get into like the real nitty-gritty of the design where you're like tweaking everything, it'll tend to like not make good assumptions. And so what you can do is you can go back through the timeline. You want to go to the earliest error and go from there. Earliest error, correct, and just keep going down the line until everything works. So that's 3mm. It's doing everything it can. It's doing its best. People don't give it enough credit. They wanna, you know, get angry at Fusion and go over to like KiCad. I have not used KiCad. I can't say anything about it. Or was it FreeCAD? And then we're going -3 as a cut. Maxwell equations. Why are we getting Maxwell equations all over my stream? All right, what was my shaft diameter here? I'll just do the shaft diameter cut. 2mm. I don't know if I have a 2mm circle, do I? I don't. I'll make it 2. Dude. Oh, hello. What? Okay, sorry. Figuring stuff out. That's a big cut. All right, and then finish the sketch. Then we take, now I don't know what the internal, I don't have anything to measure that. I could like get a drill bit and do that. Get a drill bit and then measure it from end to end, but I'll just take our 2mm hole and I'll take that all the way through. Open SCAD? Didn't somebody suggest that to me? I don't know what to do with all these suggestions. Boy, that really doesn't look like... I guess it does. I guess it does. The cuts in the different shafts are a lot harder because this is like really softly done plastic. Let's put a yeah, we'll put a fillet on the end of that. These, I guess that's what they look like. All right, we'll put fillets on it. Then we got to find a bearing. So we'll just do this here just for cosmetic reasons. Not accurate to the engineering. What is this stuff? This is like nylon. It's like that. Well, actually, let's look at the other spur gear because it's the same material as that one. Depending on what I chose in order to make the appearance somewhat correct, and I'll hit save before I do anything else. I don't want the CAD program to crash on me. Hey, you can't say that word in here, you nasty freak. Oh, you Siemens the company. Sorry, I misread that. Where'd that gear go? I guess I must have put it in a different directory. It must be in generic parts. Yep, there it is. Drive gear. This is the RC car stuff has gotten really disorganized. The more I work with Fusion, the more electronic waste I'm creating, and I really need to kind of tighten it up and figure out what my folder structure should be. Because as you work with electronics components, it makes all of these waste files where like the original component that you dragged and dropped from, from like GrabCAD onto your footprint is its own file. It's now the second file that you have. Good Lord. Appearance menu by hitting A. What are you? Peak. 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 P-A-E-K. Appearance. Now we are in plastic, but these are the opaque ones. We're looking for pay. There it is. Whole component. Done. Close. Yeah, look at us. Beautiful. Let's get that bearing, and then I don't know if we can... I don't know if we should put it on the shaft. I think we... What's that? What are you guys talking about? Oh, Solid Edge Free Edition is the best. Oh, I was just, yeah, I saw the one word and I zoned in on it. I'm a programmer, but I don't like math. Good news. You can just put equations into Fusion. It's amazing. And if you learn to kind of build your part sequentially, like on a timeline, then you can make edits to the stuff that you did previously, and it will cascade down the line and it doesn't mess everything up. It's tough to do, but if you sort of know your part ahead of time and you go through a certain process, you can base things on. This is why I always go from object to object, because if I measure that distance again, or if something down the line, I don't want to have to reprogram all of the distances. One of the things that I did in this is I measured from that same spot all the way out to that distance. That's tough because if one of your pieces is slightly off, then it won't cascade down the line and you'll have to edit multiple items. So if you do stuff as like bit by bit based on this position, based on this position, based on this, then it can really go together well and go through that last bit of tweaking and iterating in order to get all the distances right, which I'm not going to do on this part. Save. Let's find a bearing so that we can finish today. Find a bearing. What is my bearing? Spur gear model. I really want it to look like something like this, Something just weird and organic. This one's a little less so. But I don't know if we're going to be able to achieve that. This thing comes up constantly. It would be kind of interesting if I could do it, like build it in a really weak material, so when it crashes, it completely just deforms. I don't have a metal 3D printer. I don't have that kind of sintering technology. I saw one creator that Short Lurker linked me to on Discord, which was really, really cool. He has a metal 3D printer, and it's like space age looking technology. Everything was clean. And then he brings in this 1994 CNC mill that's like caked in shit. It's like, kind of like the older stuff. It's dirty. What is the dimension of my bearing? Well, it's a 3mm inner race. Outer is 7. So we're going to start with the outer. So 7mm bearing. And then our width. I actually have a lot of German viewers. I was just thinking 2mm width. So 7 by 3 by 2. That does not look like the right thing. A lot of these look like larger bearings and not the cheap one that I have. 22mm by 8. That's not really going to work. Are we SOL on this one? Are we not going to be able to find it? That's a big, that's like a skateboard bearing. 22. 7mm. They spelled bearing wrong or something? Why can't I save the part you are editing if you are in edit in place mode? It is a different mode. I work in it. Let me save the damn thing. Yeah, I don't know about that. I haven't worked with that before. We're getting fidget spinner results, so things are a little bit cursed. Everything is 22mm. Maybe if I split up 7mm, maybe we get... I don't want to have to make this bearing myself. I don't have it in me. 2287. We're looking for a 732. 732mm bearing. It's enormous. Short Lurker and I tried to work on the same file and like the same project and share it between us for the Scorpion pan. He ended up doing a hell of a lot more work. I was a little distracted at the time. And he made an absolutely amazing model for his own Scorpion-based 1/24 RC car. But we tried initially. What's this one? This one looks like the right thing. 105. This is enormous. Can it scale down to the right size? I wonder if we can scale one of the other ones down. Anyway, we tried, and it was like pulling teeth. We couldn't quite get it to work right. So I don't know how that's supposed to work. There's something I don't know. All right, so can we scale the other one down? Because it doesn't really matter if it's exactly the right part. Where's that other bearing? Balls, ball cage, seals, balls, outer, inner. How do I take this whole thing and just scale it down? Control A doesn't work. Sketches. Oh my. This is a trip. Here's how you break a drawing. Dun dun dun. Now we have all the steps here, so we might actually be able to take this step by step and roll it back. It's because I didn't have my student license anymore, so we couldn't do some team collab. Oh, did they lock team collab into the student version? That's obnoxious. We gotta figure out. We gotta make a FAQ about getting that getting into that community college class. What's going on here? No, get out of here. Hold on. So save as, and this will be 7, 3, 2 bearing. Is Team Collab a thing for CAD related stuff? I do not know. All right, take it all the way back to the first sketch. So let's see. If we do, that's -3, so a third of what, this is an interesting bearing. Wait a minute. It's got like a really thick outer piece and a really thin inner. And it only seems to have, these are like, the design gets a little different when you get down to this scale. So we'll just scale everything down by like quite a bit, and we'll just see how that goes. Because it's going to be a different thing no matter what. It doesn't quite match up. Yeah, like that first piece is still 1 millimeter, but the inner is much smaller. Maybe we can reflect that. So if I'm going down to, which one is this diameter? Is that an offset? No. Oh, there it is, 6. So this one's down to 3. This one is probably 3.5. And then this one is down to, what would that be? That would be, looks like 1 millimeter off of 3.5. So I'm going to say, let's say 3.5, and this one would be 4.5. Actually, well, then this one would be 7. So it's a little taller than that. That's kind of the design of the bearing. That's kind of what it looks like. Ooh. Finish that. And then we go one step from there. And that creates our outer shell. All right. All this stuff is going to suddenly get cursed. Oh, it's projected in. Oh, that's kind of nice. That might work, except for the ball bearing is too big. 0.5. Way too small. 7.5. 1. 1.2. Have to keep modifying it. There. So 1.2, and then that gets revolved. Oh no, that creates a sphere. This is projected from the other one. This is a weird design process. We're learning something. Can you use mouse wheel to scale while editing in FreeCAD? I've never tried it. I don't know. With Fusion, they try to push it with a cloud saving. Yeah. Offset plane. I don't know what that's going to do. I'm trying to use Fusion properly here. What the hell happened with that one? Oh, he split it into 2 pieces. Why would you do this? Oh, he's making the, okay, so he's making the bearing race. This is where the bearing is going to be. I would have extruded it along a path or something. So he revolves it, and that's going to create that cut. And so that's where the bearing rides on that part. Smooth it out, and it'll round it. See, you could have taken that circle, and you could have revolved it around the axis, and that would have done both of those steps in one. 6 of one, half a dozen of the other. What is this sketch? What we're doing is we're going through the sketches, and we are looking for things that are breaking as we change the initial dimensions of this device. All right, so now we revolve that one, and we create our inner. Wait, they just did that for the inner one. Why did they do it differently for the outer one? Is there really such a difference in the design of this thing? Where was that supposed to be? Fillet 2 is gone. Maybe we don't care. Where would a fillet 2 have gone? It might have been a separate smoothing, which it doesn't matter to us, so I don't know what these are doing. Oh, so something about what they did made extra bodies that we don't have, and then mirrored it in order to create the bearing with the inner and outer race intact. Yeah, it seems like something created extra stuff that we don't care about because it's not on the outer appearance of the bearing. That tied the whole room together. Okay. I don't know what that one did. Oh, I see inner and outer tying them together. Then just a plane. And another plane. Why are we planing? And then a pattern. What's wrong with this? Looks fine. Maybe fewer balls. Missing axis. Quantity 10. All right, that looks good to me. That's going to break some stuff, isn't it? We've made a construction that I don't know where it is. Huh. All right. Ah, okay, so that's for this stuff. So those are supposed to tie together all of the components. Where did that come from? Was that external? I mean, we don't even need any of that stuff. So I don't know where those are coming from. Was that external? Body 19. Oh, here we go. Oh, okay, so it's a sketch right before it. Duh. All right, so we'll make this. Actually, this structure does not probably exist inside of that bearing. That's for like bigger bearings. That's not for our size. Our width is supposed to be 2, by the way. It does not look like 2. Huh. So let's get rid of everything relating to the bearing race thing. So like this goes. That goes. That goes. That goes. And this one. Don't need the sketch. Delete. Okay. All right. Our thickness is still way off. Where's that created? That's this step. See if I can correct that now. So it's 2 millimeter. It broke everything. it broke everything. It broke everything. My 2 millimeters broke everything. That is splitting the body, and yet it's not splitting it in the center. Body to split. 2 selected. Splitting tools. Oh, it's that plane. So offset plane 1.5 becomes 1. Okay, and then this is gone. Let's delete that. We're back. Okay, we're still okay. This is manipulating the timeline in Fusion 360. It's a process. That's offsets. Is that for the cover? See how those are offsets so that when we change the dimensions, it's retaining its integrity and it's able to work with us. What moved? Move and mirror. Oh, to get that. And then those are the outer chamfers, which are probably less prominent than they are here. Cut and paste body. Balls. What are we doing with the balls? What does that have to do with anything? Ball cage 1. Oh, yeah. Delete. Oh my God. What is going on here? Delete. I don't know what's going on with the seals there. And then there are our boring appearance menu. There's our new bearing. That was easy. That was not easy. Like I told you, some of these GrabCAD models, people will model so much extra stuff inside of them that we don't need. Like, I don't need shiny balls inside of my ball bearing. I'm only worried about the outer dimensions and whether or not something is going to smack the ball bearing and destroy it. Anyway, our 722 is here, and it's got way too much detail, but we can get that into our... We can either make a new spur gear one, or I can... Yeah, let me just attach these straight up. So this gear gets... Because you can't remove the ball bearing from it. 732 comes in here like this. This over here. Twist it. And then we go point to point. And I go from a point that I can access to where the bearing is going to seat against. Right there. Everybody fits. Everybody's happy. No Z fighting going on. That is our spur gear. And so we've got to figure out how to get this positioned on the main drawing. And we can do that with the housing again. And the gears will probably like collide with one another, but okay. So I need to go back to close that. We're done with that. Close this. We're done with this. Close this. We never had anything to do with this. Close this. We're done with this. We don't ever look over here. Okay. Get you out of the way. Actually, get the browser out of the way. There we go. Oh, I have so much room to work now. I'm very restricted in the setup that I have with my little column on the right hand side of the screen here. I could probably make the column a little smaller and put more stuff in it. Like I could have like a little ticker thing going at the bottom and stuff like that, because everybody's got big screens now. I'm probably a little bit too big on everyone's screen, but or I could have just the bother in the corner cut out, chroma keyed. But the shop is as much a character in my stream as I am, so people love finding stuff in the background. Where did my gear go? It's in WL. So zoom out a little bit. Let's get those housings back in here. You. And then I'm going to bring in the spur gear. The scavenger hunt. I could have a sponsored scavenger hunt. Canned water company will send you free water if you find the can in the background. And then I'll accidentally have like a soda can that I left out. No, not that can. All right, point to point. That outer race. And then we go down here and we send it to outer space. We send that to that right there. That does not look quite right. What did I choose, the front one? Why is that so set in there? Oh, but it is meshing properly with the other one. Like that looks okay, kinda. But this is like sunken into the housing. Is that what it's like in the real one? It appears to be. Let's do the other one now. Oh, I actually need to, I forgot to copy. Go through that menu, and that way I can actually select it, and we'll do this kind of move. And then I'll create a copy, pull this thing out of here, flip it, flip it, and then we are choosing still the back end, because that's where it would seat up against, right there. And that goes to here. Yeah, I guess it's got just like a weirdly low tolerance on that, and it goes directly into the housing. Is it really even like that? Maybe I measured something wrong. Oh yeah, there's a much larger radius around the Oh no, wait a minute. That is exactly what it's like. Hold on a minute. Yeah, it's like right up against that. It looks like it's just directly out. Yeah. I mean, it's back a little bit. If I seated it properly, it would just go straight out of that housing. Oh no, there's a much larger radius around it. I must have measured the radius wrong on the on that circle down there, because it does look like it's wider than the one in front of it. That's fine. We don't need to correct that. What I do need to correct is moving the drive shaft over a little bit. I think it's probably colliding. Let's unview these two. That did nothing. Those are the wrong parts. Bonk. And then these two. And then we can collapse that. And then this I need to move. And this. What? Where's my... Where's it? Oh, it's trying to move bodies and it didn't select the right thing. So I want this to move. Oh God. I want to move it back just a little bit. That's probably good. Okay, so we've started to find all of our different bindings and where things are supposed to be located. This probably needs to move back just a little bit. I could probably edit that in place and just scooch it back a little bit. It's okay where it is. It is clipping a little bit, although it does seem to get to... Actually, that isn't the right... That isn't just about the right place. Look at that. Are the gears meshing properly? Close. I mean, I'm not able to view them from that angle, so I guess I'll count it. Okay, so we have all of the primary locatable components of the chassis in place right now. I need to figure out how I'm getting the battery in and out. I need to figure out, you know, how I'm holding down the servo. I need to make a plate for the front of the motor. I need to make a plate for the bearing that supports the drive shaft. We need to make something that surrounds these parts and tells generative design to leave it alone and not get in the way. But we're well on our way to being able to tell Fusion 360 to figure it out. Just do it yourself. I'm sick of you. And then it'll take the resources of the Fusion 360 team and all of their greatest computer models in the cloud, hours and hours and hours to probably run a couple of iterations on the design and figure out exactly what, you know, what's up. But it'll be pretty cool when it does. Oh, actually, that's supposed to snap to there, isn't it? Hold on a minute. That seems off. Well, if it's centered there, then it's okay, but the distance that we measured, because it's supposed to snap into this, so maybe that goes the other way around, but then why is that colliding with our bearing? Because it really shouldn't be. But I don't think the distances are wrong. Maybe I got something else wrong. This seems okay, though. So is my rear suspension too close? I don't think it is, because if I bring in the base plate and the diff housings, those line up pretty good. The pins are in the pins, holes are where the holes go. Why would then this overshoot? Maybe because it flips around the other way around, but this little D thing goes into this gear and holds it, and that's what transfers the power in. And of course the D part of the shaft goes into the... Well, actually, this other side here is a different design. Maybe that's the problem. This over here is a different design. It doesn't have that part on it. Huh. I'm okay with reusing it, though. Yeah, I don't know. There's some's a little weird, but I think we could still function with this. All right, I'm gonna wrap. I'm wrapping it up. That's enough. I'm like desiccated right now. I need to go drink a bunch of water. Hey, we've had a good stream. We had a bunch of people here, I think. Yeah, we had a bunch of people here. The YouTubers are coming in and out now. They're starting to notice that I'm uploading daily. I've got scheduled all through February. Tomorrow, when I wake up, I'm gonna have to upload a video. Hold on. Upload a video, or maybe two if I can get through it. Maybe, just to keep ahead of the inexorable march of the daily releases. I'm scheduled up to like the beginning of February, maybe the very beginning of February, and I just got through Games Month that I did 2 years ago. I'd love to do another Games Month. I've also, you know, taken out the, where is that? The steering wheels over here, the synthesizers over here. We have too much work to do. Push them bytes through the net. Yeah, we'll have a nice long archive of all of the bullshit that I've been up to over the past couple of years, so that when a friend calls me up that I haven't talked to in many, many years, I don't have to just say that I've been kind of not employed. I have a job. I'm right here doing it. All right, anyway, link the steering wheel to the synth to make it go beep. Did you see the thing that I posted in Discord? It was a what was it? It was a Twitter post. Mercedes has a mode where it derives music off of the speed you're going, the steering angle, and a bunch of other sensors for like the telemetry of the car in order to make a song. It's wild, and it's probably illegal. You're like, I gotta make this music better. I'm gonna go faster. Like, Andrew Physicist Twitch, a very special clay. And then we got the usuals. NASA is actually on with Axion Mission 3. So check out NASA. Will.i.am has a mode. Oh no. Is it just Will.i.am, or is that like a real thing? Rob was doing Pal World. I think that's a little psycho, but anyway, you guys can disseminate. You guys know where to go. Check out like the Knowledge Fellowship on Twitch, or just find a game design stream, or go touch grass. I'm going to attempt to, but there's snow everywhere. The sun has... I've got very little daylight. So Will.i.am designed the car that creates the music when he's... That's wild. So it's not a standard feature. I'm happy with that. That is so weird. Could you imagine you're pissed off at somebody in traffic? Like, get the fuck out of the... And you drive off onto the curb. Meanwhile, your car's doing like... Just because you're on, like, driving weird. Or if it starts playing clown music when it knows that you're off of the paved surface. Yeah, I really wanted to end it on that. All right, let's do the regular end command. I thought you were able to do that, but... Oh, yeah, it did come up. All right, there you go. So, yeah, there's all the social media links and stuff. It didn't pop up here. Well, there's the thing if you want to see the Will.i.am thing. But, yeah, check out, social media and stuff if you want. I will catch you guys later. Goodbye. Ooh, motion detected at the front door. I think my parts cleaner is here.